Okay, let's kick off this session. Sorry for the delay. We are super happy to be here in the Artifact office in London, UK. I would like to thank Christopher and Pascal Kodja for hosting this event and super event, first event, Genesis event of SpineDAO, the entity that we created like 2 months ago. So this is acceleration. This is the brand new world. And this brand new world begin by a human community. So what we want to create at first was human bonds between practitioner, researcher, but also patients, in order to provide a new spine care, a care based on incentive, transparency, reliability with blockchain technology. So first is human bonds, then it's data set, then it's predictive model and AI, and then it's research projects and products that we will present to you today. But first of all, I want to give a few words from Alexandra Smilek, because we are part of the decentralized science family now, and very proud to be hosted by Bioprotocol. Thank you, the BioFam. Bisous, bisous. And I let Alexandra just have a few words about DeSci to explain it. Thank you so much to be here, and have a good time.
Thank you, Vincent. Hello, everyone. Very happy to be at this Genesis event. So I'm pretty sure we're going to talk a lot about DeSci today, about the products. Even if you don't know anything about DeSci, you will be able to deep dive into DeSci and all the products that are going to be launched by SpineDAO. But first of all, maybe a small word about SpineDAO and how I met those guys. I've been in the DeSci space for a couple of years now, working with different entities and collaborating with different entities such as Molecule, Foresight Institute, Protocol Labs. And when actually Guillaume contacted me, he contacted me on the 24th of December. So I was like, okay, this is the style of those guys. They cannot actually stop working and innovating and innovating. And so that convinced me actually to come on board at SpineDAO. So thank you, Guillaume, for this opportunity, and also for this very good timing. 24th of December, obviously, right? Business meetings. And so also I decided to come on board because this adventure is a bit different from the other adventure you can actually see in the DeSci ecosystem. So brief, maybe presentation of the DeSci ecosystem that is now alive. So DeSci is a quite recent ecosystem. It's mainly an ecosystem that is trying to leverage blockchain technology in order to solve some bottleneck in how we accelerate and conduct science in terms of funding, in terms of publishing, in terms of sharing also. And so we have those 3 pillars. We know that in terms of publishing, we have some big bottlenecks in the science ecosystem and, so to speak, the trad science, right? Researchers are paying billions to actually publish what they've been working on, to have their papers and knowledge out there. So this is a big bottleneck, and I know that SpineDAO is working actually to solve some of those bottlenecks in a specific area related to spine and back related research. But also we had since 2021 this amazing opportunity to democratize science and actually reinvent the way we can fund science, reinvent the way we can actually solve this bottleneck that we called the valley of death, because from an idea for a scientist to the moment he will be able to, for instance, release a drug, you can count years. It costs a lot of money. And you have this like specific momentum that we called a valley of death, where no one wants to support the research of a scientist or a lab or a group of scientists, right? So actually since 2021, I think Molecule did this amazing protocol and amazing idea of IP NFTs, enabling actually to fund science in a different way. I guess one of the first IP NFT was an IP NFT related to longevity. And so since then, we witness a lot of different IP NFTs, also a lot of new DAOs working on like very interesting areas such as Athena DAO, working on women health, which is an ecosystem and an area that is like underfunded most of the time. So it's really, really interesting how you can leverage blockchain and those funding mechanisms to actually maybe accelerate this area of research. So let's come back to SpineDAO. So we had since 2021 those amazing events throughout the DeSci timeline. And what is interesting with SpineDAO is that first, it will be one of the first, I believe, DAO that is actually like led by surgeons. It's really dedicated to health and a specific health related to back condition, right? And it also like is working on some tooling that is actually not only like IP NFTs, not only trying to fund research, is also trying to actually come up with new tools to accelerate how we develop all the research and all the health related to back condition and spine. So that was super interesting. And then like, you know, on the 24th of December, actually, Guillaume told me that they're going to release this new tool that is actually leveraging, obviously, blockchain, but also AI to enable, to solve some bottleneck in the spine healthcare area. And yeah, that was amazing for me because like it's a completely new chapter, I guess, for the DeSci ecosystem. So I am welcoming, I guess, Jay, right, from Molecule to continue and explain everything about the bioprotocol, right?
Okay.
Thank you, Jay. Welcome.
Good having me.
That's
Hey, good morning. My name is Jay. I'm currently leading ecosystem for APAC regions for bioprotocol at the moment. And again, nice to see you guys here. And also, congratulations on the launch. And we just couldn't be more excited to work with the founders like Vincent and accelerate this. Such an exciting project that you're building. And we're so grateful that you're being a part of our communities, our ecosystem. So that's first items. But we'd like to talk here about bioprotocol a little bit and giving you guys some sort of just an overview of what we have been doing in the past, what we're planning to do at the present moment, and also looking forward for 2025 since it's January. So everyone has a new year goal. It's nice to talk about what are the goals this year, right? So we have a lot of exciting things coming up and just couldn't be more excited to integrate everything and then pushing all fronts to accelerate decentralized science. How many of you guys here have heard of bioprotocol or decentralized science? Everyone. That's super amazing. Yes. So, I have a kind of personal story of mine, of my friends, and I can just feel related to this. How did I get involved into DeSci? It probably started about a year ago. I was out in the mountains in Thailand with my biotech friends who came from Taiwan. So he's Taiwanese American. He's at stage 3 of drug development of FDA approval. So his name is Willie. So Willie is a great mutual friends of mine. My friend is dating him. So we're trying to just sitting on this dinner table, trying to find a mutual conversation that we both could relate it. I have more than 8 years experience in Web3 world. So I'm really from a Web3 space. He's deep into 10 plus years experience in biotech field. And we're just trying to be on a dinner table and trying to find a mutual conversation. And guess what was the conversation? decentralized science. So William introduced me to this project, Molecule. And it was like, hey, Jay, have you heard of this project before where they're trying to integrate blockchain and Web3 with the biotech field? I'm like, happy to hear more. We could, I could contribute 50% of my knowledge and you could contribute 50% of the problem that you're facing. Unfortunately, during that trip, it was a 4 days in mountain range, and I would find Williams at like 1 a.m. talking to a venture capital in America in US time zone. And I was just kind of get involved in his kind of just like schedules, right? Like his work schedule. And I find himself like, William, you're on the call all the time. Like, who are you talking to? Like, I'm just like kind of just work curiosities. And what I ended up found out is just literally the fact that William would spend a lot of his time talking to venture capital to try to get his medicine through all these phases. You need some sort of just liquidity and liquidities and inflows of just making this possible. And it's just an effort. He's now almost 40 years old at stage 3, trying to push this happen. He's working on a ketamine project to try to solve depression. So it's super unique field, highly interesting. And that's kind of just a problem. And I'm like, okay, this is a problem that I like to notice a problem in real life and kind of just come up to some sort of like problem statements and what are the solutions is out there to solve. But back to the slide a little bit. What I noticed is scientists would spend most of their time trying to applying for funding, and literally 20% of it is doing science. I barely seeing him on ground, Williams, doing day-to-day work according to science as much. So that's the problem that I have noticed early in my decentralized journey. Bioprotocol is trying to accelerate a biotech R&D through trying to help scientists and researchers to be able to be more bold, to be more brave about their ideas. We do believe that a proof of concept and the best way is literally to launch to the market and let the market decide how good you are as a project. And that this kind of transformation has been done in many, many years in technology world or internet world, where people just do, let's say, go up on a Kickstarters and fund their project. So it has been done in the multiple fronts in a lot of ways, right? And with a very similar system, we do believe that scientists and researchers should apply this mechanics to be a lot more decentralized and to be a lot more transparent, and also a proof of concept that's just very much quicker. If you have an idea, you're in a proof of concept. If it fails, then it fails. But the ability for you to build and then keep pushing that front is very important. We try to get researchers and scientists through the value of death. So the problem with pharma companies and I would say science for the past 40 years, we have seen a lot of mistrust. I think COVID really emphasized that. So I think the people is with us in general, and COVID really emphasizes that. And also an epidemic in the US with the Purdue Pharma, the problems that has been kind of just been brewing up, that a failure of healthcare system and pharmaceutical system can really impact your day-to-day life. If you would go on to a town called Kensington in Philadelphia, you would just see people being homeless. And that is the result of OxyContin's releasing into the market, and the painkillers. This has been a problem. So it really could impact our day-to-day life. And we do think that this movement, I would like to call it a movement, because I think it resonates with me. I got involved in blockchains and Bitcoin back in 2017, and I've been networking in very similar events like this, and the peoples and the communities really speaks for something. And the reason why I'm joining Bio and joining the decentralized science movement, because I sort of connected the dot again with that same feeling back in 2017, but now it's 2024 when I got involved in it, and I do feel the communities and energy really resonate with me with the experience I have back in 2017. So super excited. So how does Bio really works? We try to fix it by building the terminology called BioDAOs, and the BioDAOs would really stands for a company, a sub-company, right? You could really call that, but the DAO term is being used vastly since 2019. stand for delegated autonomous organization. It's very complicated, but yeah, we call it DAOs, and it's a fun term to really call it. And the concept is that trying to bring the science on chain. So what is a BioDAO? A BioDAO, if you can see over here, a BioDAOs would actually vetting and funding the promising scientific projects and be able to help them acquire a research IPs. These research IPs would be having a few options. It could be doing IP licensings. It could be a new company spin out, or it could be launching an IP NFTs. And it will be monetized through these three ways, where once the process flow, the treasury will go back into the DAO itself. So we're looking to build BioProtocol, have a lot of BioDAOs, and I will kind of just be giving more example a little bit more. So why BioDAOs? I think BioDAOs has a lot of advantages over a traditional scientific models in a few ways. I think first is capital efficiency. It kind of pool resources in a very lower innovation cost. Second would be a flexible work model, a shared IP of ownership, open access, and also diversifying a portfolio. I think BioDAOs able to directly access investor with no middle person in between. So your ability for you to be able to reach those and also decentralize your way by using governance model, that is very powerful. So you put some sort of democratic systems on top to govern how your company is being run, and you at the end able to make a decision which is a fair result with more transparencies and with a nice leading goals towards your milestones. So here are some of the success stories of our BioDAO. So BioProtocol has already working with 8 BioDAOs, and of course we're adding a lot more, but the 8s are the numbers that is already to the market through both an auction mechanisms and also will be through a new launchpad system. And VitaDAO our leading DAOs focuses on longevity researches. ChiroDAO, which is a high-impact research fields in cryopreservation. ValiDAOs that focuses on synthetic biology research. And I can maybe give 3 more examples. Athena DAOs, which focuses on women's health. Hair DAO, which focuses on hair loss. And also Psych DAO, which focuses on psychedelic researches. So you can see all the DAOs is focused on different kind of just, I would say, types of science and researches, and would like to have more and more DAOs being onboarded. So all of a sudden the bio ecosystem consists of multiple fields of science, and I think that is highly valuable. Here are some of the next generations of DAO. We have quantum biology DAO, leading by Clarice, and also long COVID DAO, leading by Rohan. So these tools are already, quantum biology raised more than $6.8 million US. I believe this was 6 weeks ago, and long COVID DAOs raised more than $2 million US, and the auction just ended. The upcoming DAO are Kyotopia, which focuses on rare disease researches. So these are very good, I would say, mind maps of how BioProtocol really works. So BioProtocol is on the left here. Inside BioProtocol, there'll be multiple BioDAOs. You can see here there are 8 inside here. So give an example, inside VitaDAO, this is an icon VitaDAO, there'll be multiple IPTs and also IP NFTs that VitaDAO, let's say VitaDAO found a researchers in Germany who would want to tokenize their researches. VitaDAO then all of a sudden already have the treasuries, and the VitaDAO can use those treasuries to fund these researches to accumulate the portfolios and then be able to launch the IPTs tokens coming out of it. Great example would be VitaFast and VitaRNA. So here are some numbers, ecosystem numbers as of January 2025. There are more than 22.7 tokenized IP values. Our community really grow to about 120,000 at the moment. And we funded more than 60 projects, and the ecosystem token holders is around 28,000. So our ecosystems, we have worked with multiple fronts. I think our ecosystem market cap now has reached more than 200 millions. And also we have worked, and also our BioDAOs and BioProtocol has worked with multiple partnerships with Pfizer VCs, leading, I would say, universities all around the US. And so we got features in Nature Biotech, and also we are in the same field. And I think last November, CCs and also Brian Armstrong and also Balaji has kind of just vouched for the concepts that decentralized science is something that's very exciting. So we're trying to merging a elite biotech talents and the breakthrough researches that they are trying to build. So, for example, if you know anyone who is, an awesome founders, which we have found one, but if you know anyone who has a dream to pursue, that hey, I've been working in this field for 10 years. 20 years, it could be 5 years, it could be 3 years, but I have noticed a problem and I want to solve it. But how do I get started? I don't want to be spending 80% of my time trying to find funding or trying to find money to trying to pursue the dreams of pursuing the problems that you're trying to solve. So with that on hand, we're trying to be the vocal points and the tools for these founders to be able to build on our protocol. And also I'll talk a lot more about how we actually help the founders achieve those dreams. So these are some of the key highlights of what BioProtocol actually provide to those founders that would want to launch their BioDAO. So we do a lot of branding and design, legal engineering, governance and operations, community building, incubations, tokenomics, and also we provide them with a system of a public token launchpad. So a lot of, I would say, biotech talents might not be familiar with Web3, but of course, I think that's going to change though. I think in the 10 to 20 years time, we're going to have an inflows of young biotech talents who Web3 become very just normal for them. They learn about MetaMask wallet or Google Chrome wallet extensions literally in their high school or in their primary school, where they already super familiar with the whole on-chain Web3 processes. So I do believe that the learning curve of that will kind of reduces. But at this stage, of course, there are going to be some sort of gap between building this, and that's how we actually filling them in. So these are some of the tangible progress that we have made. Some of the cool things that I would like to sort of raise. SpineDAO has actually launched their first product in Thailand, and I got the FDA approval within 2 weeks. It's a combination of Spirtamine and MNN. So those are some of the exciting front. We do see the product actually reaches the market to consumer. Also, another product that I want to highlight is the follicle shampoo that's being launched by HairDAOs. Move on to the next slide. So Bio becomes this sort of meta governance protocol where we actually, I think these flows are being kind of highlighted, but these are some of the example of the VitaDAO flywheels, which, let's say, for example, they have done a $10 million raise with a $5 million funded, and now they're accumulated more than $6 million in IPT values. So yeah, we highly believe that blending a DeFi and also the DeSci together, we will be able to some sort of kick off a new conversation around science, finance, or sci-fi, where it is fully automated liquidities and creation protocol for our scientific communities. These are the new, I would say, flow of the new launchpad. This is about to be, I would say, going live in hopefully end of February. So we are going to, with this new launchpad, we're going to increase bio token utilities, and also things are going to become a lot more permissionless, with our new Launchpad 2.0 become a lot more, I would say, maturized and also suiting a lot of things that we're actually building. And we can see there are split into 3 phases. The first phase is the BioDAOs that say apply to our website, right? We selected them. They are going through a creation phase. A creation phase will allow bio token holders to be able to participate and do some sort of proof of concept voting, whether this project is ready to be going through the next phase. So with that, bio token holders, which is now listed in multiple centralized exchanges all across the world, with Binance, OKX, Bybit, all of these exchanges you can name off. So the liquidity is there. We are now trying to bring in that utilities, and we have a lot of bio token holders who would like to participate and also voting. What I mentioned earlier, that the speed of proof of concept will be much quicker, and be able to do that through our new Launchpad is an amazing experience, we believe. After the creation phase has been completed, they will move on to a second phase, which is a funding phase. And the last phase will be the AMM liquidities, and I can talk about that. So the funding phase, we are planning to use 2 types of system, both on the auction mechanics and also the bonding curve. And we do believe that these 2 systems are suitable for both 2 types of DAOs that we have experienced. So one of them would be the DAOs that have a communities already, and another types would be another DAOs that a little bit more moonshot projects, that the values of IP were coming in a sort of later stage. In the first one that I mentioned, in the one that already have the communities and the concept is very easily to digest for the audiences, those one might be matching more to the bonding curve mechanics. And the second one, which is the moonshot project, might be a lot more suitable for the auction system. And the last stage, if they graduated with funding, they will be moving to an AMM liquidity. So we'll be able to deploy liquidities through decentralized exchanges where people can become, your BioDAO's project become tradable on the decentralized exchanges where users, investor can literally trade it, your tokens. So our early success sort of has this accelerated interest in, I would say, the growth of DeSize, and the compounds that is a success is being kind of embedded within this bio flywheel that I have put it here. So first phase is an attention phase, right? So we do see the attention at the moment where I think DeSci become this narrative that a lot of Web3 seminars and a lot of Web3 events now slowly talking about it. And people are trying to figure it out, what do we do with this? How do we make this better? And what are the success there? Once the attention phase is sort of maturized, which I think now the mindshare of DeSci is maturized within our kind of closed loop group. But if you go down to street, no one will really know what the heck DeSci is still. So I think it's nice. It's such a nice phase to really build, right? Because you want to be early, then you want to be, too late to build. So it's an awesome phase where the attention is in such a small, unique groups of people. And how do we leverage on that? I would say at the moment, we see an influx of talents from all around the world, literally all around the world, where people and scientists and researchers actually reach out to Bio Protocol through our networks to here, this is what I'm working on. So we see this inflow of talents, and we're kind of just moving to the second phase here where we have influx of talents now, where we'll be able to take the best talents and the best projects more than ever. And with that, the best ideas in a team will rise sort of to the tops, right? And the next phase will be really on the retails and the VCs capital, where it would actually increase the funding to solve the problems. And the last phase is the tooling and the implementations. So here's the teams. Maybe you guys have sort of seen our team before, I've talked, but would love to sort of just give a shout out to, I would say, Paul, James, Clemens, Nate, who has been kind of just the core teams of building this journey. We do see sort of, I would say, a proof of concepts that is being vouched by a lot of people. I think we have Vitalik visited the DeSci booth back in Bangkok in November. We have CC's kind of join in the conversation as well. And a lot of people actually sort of tweeting out and talking about this idea, which I think is great. I think it's great to see the ideas of DeSci being pushed and being pulled. And it's very healthy. Such a fun space to be in. We kind of integrated into a super unique conversation and fun conversations all the time. But yeah, excited to see what the future bring. Here are some of the roadmaps. So Meltdown launched in 2022, and in 2024 in Q1, Bio spun off from Molecule, and we're going through a sort of cohort, which is ended, cohort 2. And I think in the next phase, we are going to introduce a DAO tooling, and also we increases the exposure to an AI agents and also automations into bringing this artificial intelligence into helping both BioDAOs and also bioprotocol to be able to leverage this autonomous way of working and be able to use AI and also provide an AI tool for Vincent to be able to leverage on. So we are excited for 2025 to be able to move forward with that. Yeah, that's all from my side. Thank you so much for having me today.
Thank you so much, Jay. Thank you, BioFam. Thank you, Paul, or the guy, James. I mean, it's a huge story with bioprotocol, because I must admit that it began in SciCon San Francisco, 2024, meeting those guys that are incredible. And I remember having a conversation with Jose, the lawyer. Shout out to Jose, super cool. He described the DAO as a tennis club. The DAO is a tennis club. We are a spine club. So yeah, get your token. Put your token in your favorite tennis club, and I hope that your favorite tennis club will be Spine Club. And let's curate. Let's leverage some funds to do our project. I think we're right on time to present the team, right? The core team. So maybe first of all, I want to introduce you to my man Basel. Do we have Basel? He's like Basel Diebo. Live from Providence. It's 4 in the morning now in Providence. Basel, can you hear us?
Just say that.
Okay, cool. So just make a few words, Basel. How did we meet? What is your insight on the DAO? What are you doing?
Yeah, thank you, Vincent. I'm very excited to get this opportunity to be part of really big movement and a big project that kind of brought people together from all over the world. We met many years ago, almost 11 now. We both worked for one of our core team members, Dr. Lafage, who's decided to make a mistake and hire us as researchers, one from France and one from Syria. I don't know how she feels about it now, but in general, the way I feel about it today is I think a new hope begins, a new hope for patients to see how innovation, collaboration, and decentralization unite together to shape the future of spine care. I think with SpineDAO, we are really aiming and will break down a lot of barriers. We got to empower a lot of minds across the world to collectively kind of advance research, optimize treatment, and really make sure that every patient benefits from a shared knowledge that was totally separated in silos and now represented in a truly global community. So I'm extremely excited to be part of this. Maybe today we are in a small room of London, beautiful London, But I believe one day we'll be sitting in a big conference room with hundreds, if not thousands of people getting excited for what we do. So congratulations to the team. Congratulations to everyone who any efforts for us to meet today and establish this new era and then new hope for spine patients in the world. Thank you, guys.
But like just
Thank you, Marcel.
yeah, give us some background. What are you doing in your daily life?
Now, I'm not practicing spine surgeon. I take care of scoliosis patients across ages, from teenager years all the way to nowadays. We see a lot of patients in the 80s and 90s that seek treatment, want to be active, and expect from us to get the best treatment possible based on data. I also have my own manufacturing company, or a company that designs implants for spine surgery, and it's just I have my little dog as well. I have two pets, but yeah, it's exciting. I'm actively practicing spine care, and I see the inefficiencies that you all saw in the spine world, and this is just a necessity, and a big movement that we're doing here, that will really provide better care to patients in the next decade. It's gonna be amazing.
Right. Thank you so much.
Great, Marcel. Thank you so much.
Yeah, I know you have we love you, Marcel. We love you so much.
Maybe you can present Virginie now. You have to present Virginie. Your tata.
Ladies first. Yeah. Let's introduce Virginie Lafage. So Marcel told that maybe she made a mistake. I don't know. Did she make a mistake? She will tell. We met Virginie in 2013. I came from France without like a kind of a bad background as a surgical resident. I was like the underdog. And she put me out of the street. My mom is always saying that to me, that she's saying like, just save your life. Just save your ass. And maybe you can like introduce yourself, Virginia. What are you doing in the DAO?
Yeah, I did feel it was a mistake for about 10 years. And now you're starting like to make me proud. Just starting. So I'm Virginie. I'm like a full-time researcher in New York. I've been in New York for 20 years. I still have my French accent. I think like it's going to stay this way until I die. So I'm deep into traditional science. That's what I do. I work in a hospital, first at NYU's and HSS. Now it's like Northwell, which is a network of about like 27 hospitals and counting. Also collaborating with some study groups. So we are pretty big from an academic point of view. But it's very slow. It's very slow. And for example, in my hospital, if we want to collaborate with another academic institution, it takes about like 4 months. 4 months to set us the paperwork. If we want to do a clinical trial with industry, it's 8 months to 1 year just to get started. If we want to evaluate new technology, well, it's never. Because the hospital is going to say, like, what do we get? And I'm like, we just get the chance to see what's going on. And this led to some frustration, because basically right now we're working with classic statistician and clinician. And you can go only as far with those skills. And I see like around us, like there is like fantastic people that are maybe like from different area. So we talk about AI, but what about like biomechanics? What about like deep learning for imaging? And if we want to push the envelope like a little bit further, we really need to collaborate, and we need to do it fast. And I think that's what excites me like about the SpineDAO. Also from a knowledge sharing point of view. If you think about it, like we are publishing, and then nothing is happening with those papers. The only person that reads this paper is they want to publish on the same topic. And then like the impact of publication do exist if you're willing to wait like 15 years. And there is actually some data on that. Like you publish, you need someone else to publish on the same topic so that there is some evidence. Then if you're lucky, like all those findings are going to be picked up and end up in guideline. Then somebody is going to make a decision, and then you repeat. You know, I know I'm giving like maybe 20 talks a year. For the past 10 years, I've been talking about the same thing. You know, I do update my slide once in a while, but I'm always invited to talk about the exact same topic because it takes time. You know, it takes time, and academic communication is fun. You know, you're very proud, you're on the podium, everybody like clap at you. But then the clinical impact takes very, very long time. And so I don't know where we're going to go with SpineDAO. You know, I'm like, let's be honest. But I really hope that a few things. First, we're going to disseminate knowledge. Then we're going to create some tools that are available at the point of care. Because as a clinician, when you see a patient, you're not going to go on PubMed to see like, let me check, you know, what is like the most recent science. You know, you want a tool that is available when you see patient. You want a tool that helps you to make some decision. You want a tool that is way more than just like a basic calculator. You want the technology to be available. Again, it's very, very complicated to do that in a classic academic institution because all those tools need to be vetted by the IT systems, and you have to deal with the security. So we need a new way to bring value to spine care. And I really hope that's what we're going to do.
Thank you so much, Virginie. So Virginie is so humble that she didn't introduce herself properly. She's just running like the biggest study group in terms of spinal deformity in North America. She's working in New York City, and maybe we can now introduce my Guigui, my Guillaume Longeon, and how did we met? Because it's very related to human bonds and to friendship and human community. So yeah, he just gave me a phone call in 2020 saying, "Hey, do you want to create a spine surgeon community in France?" I was like, "What? You want to build bridges? I want to build bridges. Let's go!" And then we did that. Can you introduce yourself and say maybe a little word about spine research community?
Yes, just a few words for me. I'm Guillaume Longeon. I'm a spine surgeon in Montpellier in south of France. I do a lot of spine surgery. I do only spine surgery and a lot of endoscopic surgery. I share this part with Joseph, is just coming. And I'm very proud to be at the beginning of the spine research community. Just show the pullover, yes. And this is a big community with 70 surgeons from France and also Italia, Belgium. We have a lot of friends. Yes, we have a lot of friends, and we try to be more and more each year. And now we are very happy because we create a setup for the surgeon and for the patient with a big data set. Now actually we have 300,000 cases in our data set. It's very huge, it's very important. And now we have to find solution to be better, to have better follow-up and to have better data. And it's also why we engage the Virginie for that and to help us for that. And we met in 2020. It was a journey for me. It was a travel, and I was very happy to meet Vincent, and he helped me to create something very huge. And I think now I try to help him to create something more than huge than the spinal research community. Thank you, Vincent. Thank you for what you did.
Thank you so much. So yeah, spine research community was the first step. I mean, bringing all these surgeons together. You have to know that the spine surgeon has a lot of pressure, but also a lot of ego. So putting spine surgeon together and speaking doing restaurant, having good wine and good food, it's the main thing. But Then we need to talk about our surgery, of what we do on our daily practice, and also to talk about complication and failure. And for us, I think like talking about complication and failure is the beginning of saying something, to recognize that our art is not perfect. And when you check the literature, there are high rate of complication. When you deal with spine deformity, it's like 30 up to 50% complication rates, up to 30% revision rate at 2 years follow-up. And it's a huge burden. So creating SpineDAO, and my man is entering because I was waiting for him. He's here. The last one, not least, and he will introduce himself, Joseph, and we can go on identifying inefficiencies in spine care, but he's just right on time, coming from Marseille, France. This is my man, Joseph. Joseph, come. The meeting with Joseph was kind of something. It began by a restaurant with Guillaume in Dijon, and now he's in London. Come, Joseph, and introduce yourself to the community. Yes, we will explain that just after that. Now you can see the core team is all together. This is my man, Joseph. Can you introduce yourself quickly? Stay close to the computer because we have some issue on the audio.
Sorry. I would like first to thank warmly Pascal Koja for welcoming us here, because it's one of my friends. And I would like to thank also some of friends of mine in the assistance, and a childhood friend, Jean-Louis Bourgeois, and Nicolas from my country. I'm a neurosurgeon. I'm specialized in endoscopic surgery. I come from Corsica. I think you know Napoleon. It's the same country. I'm part of a community of surgeons and maybe of buddies, I think.
Oh, yeah.
And maybe it's one of my skill to be your buddy. And maybe,
to build bridges.
Yes, very exciting to be here with you.
Thank you so much, Joseph. And core team, we are all together now. So very proud to introduce those guys. And as I said, like building a community and speaking about failure, it's quite complicated for spine surgeon. And then, so we had a WhatsApp group, we had a annual event, and we were thinking about, well, maybe we can scale up like globally, because now we have like tools to communicate globally, and also because Joseph and Guillaume are well-known surgeons in the endoscopy, spine endoscopy game. Basel is super well known in the Basel and Virginia are super well known in the deformity game, because you have like subspecialty in spine surgery. We were talking about the inefficiencies of our art, and the inefficiencies of our art, it begins by the appointment of the patient. So maybe we can see those slides on live stream or no? Yes. Yeah. Okay. Cool. So just going over those inefficiencies, and when we will go deeper after the break on each project of SpineDAO. But going back to those inefficiencies, it comes from the appointment of the patient, because you have to know, and everybody has to know, it's super important to hear that. As a surgeon, and it's well shared globally with all my spine surgeon colleagues, in the office, we have up to 90% of non-surgical candidates. So it's a burden, first of all, for the patient, because the patient, he has to wait like 3 months, maybe 4 months to have this answer. I cannot help you. I mean, you are not an appropriate surgical candidate. I can put screws and rods and cages in your spine, but it will not improve pain. It will not improve your performance. So he has to wait all this long. yeah, we can explain his disease, we can see the MRI with him, we can having his word on his pain and maybe having him some relief, but we cannot provide the good solution for him. So it's a huge burden for the patient first. And also it's a huge burden for us because to fill our operating room schedule, to fill our operating room schedule, it's like about 7 to 8 patients per week. So you need to see between 80 and 100 patients per week at the office. And it's not sustainable. I'm doing that in private practice since like 6 to 7 years. And it's a huge burden because you have like only like 7 to 8 minutes to spend with the patient. And you have to you have an automatic rhetoric. It's like you're a robot. You're like, for how long you are in pain? You have to be very, very concise. And it's like super difficult for us to sustain that. It's also a burden for the payers. I mean, the state, and we're supposed to have the best healthcare system in France. I don't know, but the state pay for the consultation and also the insurance pay for the consultation. So this consultation is inappropriate for 90% of the case. So it's like super weird. That's the first inefficiency. Second inefficiency, I have my surgical candidate, like one of the 10 patients that I see in my consultation. I have my surgical candidate. What do I have to propose in terms of surgical strategy to him? There is a huge variability, high spectrum of surgical strategy without clear consensus. And I cannot say, well, in your case, if I put a cage, you will have this improvement. I don't have the tool to make a prognosis and to make a clear agenda to the patient. It's very funny because on our WhatsApp group, we used to share some cases. And when someone shares cases, the spectrum of answers goes from minimal invasive endoscopic decompression to instrumented correction and reconstruction, lumbosacral reconstruction with like tons of screws and rods and like super aggressive method. So we need a clear consensus on what we are doing, because like proposing a surgery that is up to 50% of complication, 30% of revision rates without a clear truth machine, it's not sustainable. And I remember this YouTube video, Gooby and Dooby, Jay said it to me. And his word was totally like this. I mean, we need to improve our rationale for surgery. And also we need to give a solution for the 90% of non-surgical candidates. And it's super important to bring surgeon and other practitioners together to have this discussion saying like, this patient is not an appropriate surgical candidate. What can we do, guys? Like pain manager, Bart, what can you do for this guy? Shout out to Bart, he's a pain manager. So we are not only surgeon here, you also have medical people. And also like physio, but also other therapeutics. I mean, nutrition, dietetics, I mean, physical activities, mental health. We want also to bring other DAOs to our system to provide multidisciplinary solution for those patients, because it's not like I put 2 screws and then it's done. It's not a car. It's a human body with biologics. It's super important to bring all other skill to this specialty. So the third inefficiency is like, I don't want to see well-being patient post-operatively in my office. And it's kind of a bad word because I love to see patients and I love to talk with patients, especially that are well-being after a surgery, because I'm like, yeah, I'm the best. This guy is hunting again, he's swimming again, he's doing his gardening again, so I'm super proud. But in fact, in terms of efficiency, this well-being patient post-operatively take a slot that could be taken by someone who is really suffering. And it goes with the third project. We need to have tools to monitor patients like with Internet of Things, connected object, to identify early complication after surgery and to be able to act properly, but also to give a patient the agenda of his post-operative journey with milestone to achieve in terms of performance, walking perimeter, and physical activities. So we are not tackling huge genetic stem cells, robotics, etc. We want to tackle like simple thing of our daily activity, like having the appropriate care at the appropriate time for patient, increasing the surgical candidacy in our office hour, and also having a clear consensus of what we do and be able to monitor the patient after treatment, could be surgical or not surgical. So I don't know the time. Maybe we can, because we are going deeper in these problems. If I have like just a few minutes to say on our Spine Journal and Spine Archive initiative, stay online, because all this research has also to be in open access. And I love this concept of anti-PDF, saying like we need to provide a research that is understandable to everybody, from a biomechanical engineer to a surgeon, to a farmer, to a baker, for everyone. So this will be tackled by Virginie and also Nassim. Shout out to Nassim. If you hear us, we will go deep in those topics. Maybe after the break, we can do that.
Maybe could you explain or democratize the concept of the DAO and how it's for the tokenomics?
Absolutely, we can take time to that, because Jay did a super presentation on bioprotocol. But the thing is, we will be in my knowledge, I don't know if it's true, but I guess that we are one of the first surgical and clinical DAO. So it's a non-export land. I went deep to tokenomics and governance since like maybe a year, and I still don't understand fully the concept. But we want to create a tokenomics that put incentive for the patient, the practitioner, and also the researcher. So what we imagine is to create an allocation, like a data sharing pool, in order for the patient to have incentive to share his data. So first of all, you have to know that in our system, it's a patient exclusive owner of the data. The patient is the exclusive owner of the data. Insurance, we don't own the data. Insurance don't own the data. Nobody but the patient owns his data, and he has the right to share what data he wants. If he wants to share all his demographics, clinical data, morphologic data, great. If you want to share just a part of his data, it's also great. And he could share his data in exchange, having a medical advice, like what you are sharing looks like in our data set. It could be a surgical case, so maybe we could have an appropriate appointment with a surgeon. And also, by sharing this data, you get some tokens from the Spine Club. So you're part of the Spine Club now. And because you're part of the Spine Club as a patient, maybe you're part of the Spine Club as a contributor. To have maybe to share your experience in terms of pain and in terms of disability, that could also like make us think about like more your situation. And from this data, so patient earns some token, practitioner can earn also some token to labelize this data, to say out of this vignette, on my experience, this guy need a surgery. He's an appropriate surgical candidate. Also, you can labelize this data to say, what is the pain generator from this data, like clinical data, but also we aim to use LLMs on MRI reports. and to say, yeah, this pain generator is here. This patient is a surgical candidate, yes, no. And if he's a appropriate surgical candidate, what surgery would have been done, in my opinion, of expert? Fixation, using screws, instrumentation, only decompression. That could be one of the label strategy of this clinical vignette. And from this labeling, the expert could also earn some token. And by doing this, we want to empower practitioner and also patients, but we want also to empower researcher by publishing all the analysis from those data sets and put incentive in the researcher saying like, well, if you collaborate in publishing those analysis, you will also earn some token. And if you review, you will also earn some token. So it's like the research hub system and other system like Nobel, etc. And I'm super proud because I enter in real life DSI through the SciCon in 2024. It was hosted by Research Hub. So I had the pleasure to see Patrick Joyce. And it's crazy because we were DMing on X, and I think he could be online. So I say hello to Patrick. And it could be a huge teamwork working on publishing some insights from our analysis. Yep. Alexandra has a question?
Yeah. I just wanted to know if you could agree on... Wait, I need to come closer to you.
Yeah.
I feel like I can grasp the SpineDAO concept as being actually an endeavor to help patients with pain, because like I guess like I was like looking at the statistics and like there is like hundreds of millions of people experiencing back pain, like 600 millions of people on Earth, right? And so as I can see, like people are actually like wandering for a very like extended period of time in order to find like what's the cause of the pain and who can actually help with the pain. So what you are doing actually at SpineDAO is like you start with a community of specialists, right? Whether it is like surgeons, kine, and other specialists, yeah? And but pain doctors, exactly, pain doctors.
Pain generator.
There is a pain doctor here.
You have Bart.
So DAO community is super important actually to gather all the information and all the data set in order to improve the way we can help people with back pain, right?
Yep,
so
absolutely.
At every steps, because you're going to release tools at every step. So first step will be like, how can I find the specialist? Should I see bots or should I see Vincent to help me? And then you have the second tool that is like the practice. Like I can, as a specialist, I can tap into the data set and see like, what's the best practice? What is the practice in United States? What's the practice for this pain in Europe? And then third tool will be also the tracking part. So once you see your specialist, then you can like track, improve, heal, etc., etc. So you have like 3 steps.
Exactly.
But everything is about pain, right?
Yeah, like pain and disability, pain and performance. Because when it comes to elderly people, they have to say like, I won't be as performant as before. So it's a super difficult part of their lifetime because they were performant, they were able to swim, they were able to walk, they were able to see their family and having social activity. And because of their spine damage, like compression of the nerve, arthritis, instability of the spine, deformity of the spine, they are not able anymore to do those activities. And then it leads to emotional issues. And you cannot separate organic damage with emotional issues. So you have to deal with looking at the pain generator in terms of morphologic exam, clinical exam, etc. But you also have to deal with the emotional consequence of this. And it is not a part of our learning process as a surgeon. When you want to learn as a surgeon, you go to the cadaver lab. We will see all the tools that we have, like with Nicola and Federico, later in the day. But you are not educated to properly take in charge those emotional issues. So you need people. You need people from, I don't know, other DAO. I mean, I met Balash in San Francisco from SpineDAO. Super guys. Let's work on that. Let's work collectively on spine issue. And also, from this experience, because we are beginning with spine, maybe we can scale up at all the musculoskeletal system. I'm saying that because I'm watching to Michael Shelley that will be presenting the filter project just after with Guillaume. He's a shoulder surgeon, and we know that there are a super close link between cervical issues, herniated disc, cervical myelopathy, and also shoulder issue. It's super linked. So let's bring other subspecialty on spine, like new biomechanics, cellular biology, injection with BART. Let's put other surgical skills like hip, knees, shoulder in that, and let's provide a whole musculoskeletic solution to the patients worldwide. Guillaume?
Say maybe that it's a non-profitable organization, SpineDAO.
Absolutely.
After that, we earn a lot of money is to win.
Yeah, sure. So basically, as I said, it's a tennis club. It's a spine club. So when you enter the tennis club, you just earn some tokens, and these tokens allows you to be part of the spine club, and so but also be part of the governance system, so you can vote on the different decisions of the DAO. And the token is, as I said, a utility token. But from this research project, we also want to make products, and these products, if it helps patients, okay, let's work with medtechs, let's work with insurance, because imagine that if a patient has to see like 7 to 8 different practitioners, and with our solution that will be presented just after filter, we can reduce it to like 2 to 3 consultation, so we can spare money from the insurance. So maybe we can propose a partnership with the insurer. So the insurer will enter the spine club. So he will also buy some tokens. So let's work on this spine club system, and let's also be the Web3 portal, the new cryptocurrency portal to spine surgeon, to medtech, to insurer, to say, well, usually when we can talk about investment. I mean, it's Warren Buffett that says, when I don't understand something, I don't invest it. No way. So, like spine medtech, insurer, spine surgeon, pain manager, you know about spine care. You want to be part of the club. So let's join the club. Sure.
What's happened? For example, I'm a client of your solution. I take in each token. I say
exactly. You want to have the product. You want to develop the product. Buy it in Spine token. Buy it in a part of USDC. It will be part of the treasury of the Spine Club, maybe 70% USDC, and buy it in Spine token, in 30% Spine token. So you need to get tokens on the market to be part of the club. And those tokens that will go back to the data sharing pool for the patient incentive, for the researcher incentive, and also for the expert labelizer, but also for other projects. We will talk with Nassim about being the world repository of spine science, and it goes to the aim is to digitize old talker on spine science, and we have like huge announcement to say. We will say that later. Maybe we can partner with Maxime. Maxime is performing like one person surgery. Maybe you will talk about that like later. But yeah, let's partner with him and give him some spine token to his action. So yeah, it's a spine club where everybody can join, and our project will lead to products that will be sell part in USDC and part in spine token for everybody to join the spine club.
And then at the end of the SpineDAO, do you have employees, or you think that are just
It's contributors. Yeah. I mean, we may have contractors. We are not at the step of to do contracts. We are doing that since 60 days. So we are just having contributors and people from the Spine Club.
At the end, you think we can have some employees?
Yeah, sure. At the end, we will be a multi-billion company. I don't know.
And what's happened with the treasury at Champion? Because if we are not unprofitable organization, what about it?
We'll have to have a talk together and make maybe a LLC or for profit, but it will be like way after. For the moment, we are just seeding the ground. We are just building bonds between human people. We are training models and building products, and the selling project will be after. So what I propose is to have a quick break, and then we go deeper in the project. So let's go. Bisous. See you.
Okay, just go. We want to present our first project. This is the filter project, and Vincent just explained the rationale before, but maybe I can again on the rationale just after that. The goal of this product is to treat the right patient at the right time. This is very important because we just talk about we see too much patients in the wrong timing. Sometimes the patients wait for 3 months and you have a big side effect from 3 months, and he has very lot of pain, and it's not a good solution for him. And also for us, because sometimes we see patients that they're waiting 3 months to see us, but they are just back pain and they just need a physiotherapist. Okay, and this is the rationale of this product. Okay, and I just want to thank Michael because he will explain this society just in the beginning of the afternoon to explain what is sciencer. Thanks, Michael, to your help, and thanks for this product. Just talk about that. 3 months delay, it's just time for the patient, also sometimes for the surgeon. And we want to treat now right patient at the right time. For the patient, if he waits, it's a lot of stress, pain, he could have some sickle, loss of time, loss of money, and it could have some mental health problem. For the surgeon, this is my experience. In 2024, I saw 3,000 patients in clinics, and I operate just 300. This is a 10% transformation rates, okay? But I spend 50% of my time in the clinics and 50% of my time on the OR. And also my money came 90% from the OR and just 10% from the clinics. And also for me, it's a much better day when I am on the OR than when I am on the clinics. The clinics, a lot of time, it takes me some stress. It's not a good day for me. I do my clinics on Monday and on Wednesday, and start a good day for me. And I don't like this day. I like the UI. And it's why for us, we have to find a solution to be less stressful and to be better for the patient, but also for ourselves, because we have to have a good health for the rest of our lives. And also for the public system, I think they lose a lot of money because we have a lot of work arrest. We have lose some productivity for the patients. It could be also a political problem, and also for the private results, it's also a problem. They lose a lot of money if the patient is not treated at the right time. And it's why we want to find a solution to a triage patients. And we want to create a tool which I will show you a quick demo, but I will we will try to create a intelligence tool for the triage patients. This will be based on the patient interface on web, on an app, and we create an algorithm with Sciencer from 3,500 patients. We think about this solution in the French system, because in France everything is set up with Doctolib. Doctolib is a solution to find an appointment with a surgeons, and we can put maybe the filter project, we call it Smart Rendezvous, directly from Doctolib. For example, if the patient choose a regular date, this is the solution for me. If you want to take an appointment for the first consultation with me, you have a 3 months delay and more than that, because this is the 12th of May. But if you choose more dates, you can have more dates after that. But if you click your Smart Rendezvous, maybe you can have a better appointment. And this is the same thing. This is our website, and we can have two solutions: classic rendezvous from Doctolib, or maybe the Smart Rendezvous. And this is why what we want to do now. We almost set up everything, but this is an explanation. This is our website. You see, for example, I did it yesterday. I click on rendezvous, and I see this is the 12th of May. At this time, we don't have Smart Rendezvous, but at the end, we hope that we have a Smart Rendezvous button. And then we go on the SpineDAO, and the patients sign up. It is a patient, and then he chooses me because he already chose me before, and he validates that I'm the good surgeon that she wants to do, to want to see. And then the patients enter some little information about herself. She explains what is this problem, and then she click on 10 questions on this page, and then 10 questions on the other page to explain what she have, the symptoms, the duration of the symptoms, if she had a lot of pain on the morning, on the night, everything. She explained everything. Then she answer for this 10 question. This question is the disability index. It's very important for us. And then the patients have, now the surgeons do a sign up on his interface. And the surgeon have a lot of demand, a lot of requests. And for example, this is the first patient, and we see everything. We see that the patient has an important disability, and he has a probability to be operated. This 33%. It's a big probability to be operated on the next year. And this part is very important, because with this information, the surgeon could choose to validate the previous rendezvous or to move forward the previous rendezvous. Okay? And for us, it's very important, because it could help. And at the end, if we move the patients receive a text message and see, okay, your appointment will be now in 3 of March or 6 of March, much before the date of the appointment that we already chose. This is what we already done. This is demo for sure, but I think this is the concept that we want to develop and to be sure that everything's okay. And we try to put this solution on the market quickly, but we have to validate some regulatory stuff, and so also why Jean-Marc and Bruno are there, and to help for that, because I think we need a CE market for the Europe, but also a market from the US to validate this concept, because we use data from the patient, because we manipulate some data as data. And that's why we have to be sure that everything it's clean for that. For the business plan, just to explain, in France, but because I'm French surgeon, I think we can pay maybe more than 1,500 by years for this kind of solution. Because if we move from 10% rates of operation just to 20%, it's not a lot. I think it's feasible, but I think it's huge for us, and it could be very helpful for us, and that's why we think we could approximately sell it at 1,500 euros by surgeons. Maybe we can, and it depends of the country, but maybe we can sell also this solution for patients, and patient could pay for example, 10 euros by requests. But also the big solution is for the private assurance, and especially in US, Basel sailors, before see a spine surgeon, the patient takes 5 or 6 rendezvous before that, and at the end, you see the spine surgeon. And I think the private insurance could be very interesting to pay maybe 50 euros or more than that to avoid maybe just 1 or 2 rendezvous, because it's more than 100 euros in US just for 100. And maybe also we can sell this project to Doctolib, or for a docpreneur. We have to set also the price for each request. But I think this is a huge market, and this is a real problem for the spine surgeon. And it's why we think that this would be a very, very interesting project for us to change our life directly on the daily practice, and for us, but also for the patient, because the patient don't have to wait too much time to see a good specialist. And that's why we think it's very important. We try to finish this project in 2025. We have to work on the C market also with Cortex. After that also, because we just do this solution on medical data, not on the image, not on the MRI reports, but we have to set up something to integrate with the image report, maybe at the end also directly the image. And maybe also because we work with Michael, we can do an extension for the other specialty, but I think it's the same thing for each patient and each specialist and practitioner. Thank you for your attention.
We have like 2 to 3 minutes for question. Great presentation, Guillaume. I wanted to ask, this algorithm was rolled from how many patients? How does it work? Maybe Michael could give you some.
On the beginning of the afternoon, Michael will explain everything and how it's work with Sciencer. But we take a data set from 3,500 euros, 500 patients, and we could be a lot of more because we have more data in the spinal research community, and also we just take data set from my data set. But maybe we can also propose to each practitioner to have adapt or special algorithm needs a little bit on his data. Sure, of course, it would be interesting.
And also maybe we can announce that we want to have, because it's only on this algorithm was run only on French data, and maybe we could enlarge the data set worldwide by the dual incentive system, saying for every patient that wants to have an advice and maybe come into the Spine job by Spine token incentive, we want also to make this AI agent available for this AI agent available for all patients worldwide, like putting your demography, clinical parameter, maybe MRI report to be read by an LLM, be incentivized by Spine token and having a medical advice. And from this data, create a vignette that could be labelized by surgeon to improve the model and to improve the algorithm. That's on the roadmap. Thank you very much. Yes. Now now we're gonna go to the Decide project.
Yeah.
So we talked about the appointment system, smart appointment system, and now we're gonna talk about when I have my surgical candidate, my 1 on 10 patient that you see at the surgical candidate. What do I have to perform? What kind of strategy I have to perform? Is there a possibility to have an AI-assisted solution? And it will be presented by Virginie Lafage, but also Bruno. We didn't introduce Bruno Perou. My brunette. We call him our brunette now. It's the brunette of SpineDAO. You can come there to have your beautiful body on the screen live stream for the 100K viewer. We forgot to thanks. Absolutely. And I can just take 2 minutes to have a super wonderful thanks for our team, for Scott's team. Unfortunately, they were able to be there in London because of visa issue. But anyway, they are with us remotely. So big shout out to Scott, Itepu, to Anuda, to Hamzat, to Sean, Noel, Eugene, all the guys from Nigeria that are working with us. You are super important for us. You're doing a super great job. You're part of the community. You're on the website, and if you want to see their face and contact them, don't contact them too much because we want them to be fully involved in SpineDAO. Shout out for the Nigeria team.
So I already introduced myself, but you want to introduce yourself so that's like a...
Yeah, briefly, my name is Bruno Perrault, and I am CTO of Cortex Virtual Intelligence. My background is AI and data science, mostly, and also software development. And I've been doing this for 12 years now, so it's quite a long time. And I have a PhD in physics, which has nothing to do with AI, but you have to start and...
So I'm going to talk about I'm going to do the first part and then transition for everything that is technical. So, but before I get started, I thought maybe it would be nice to talk a little bit about spine. Yeah. Because we're assuming like everybody knows everything, but maybe it's not the case. So I want to start by the fact that a normal spine is already quite complex. You know, we have like a ton of different vertebrae, including like 24 of them that can move. At each level, we have like 3 articulations, like the disc and the posterior element. That's just for the bone. And then you have the ligament, you have the vascular structure, like just name it. You have everything that you want to stay away from. It's also quite complex because each individual subject has its own spine, including like a different shape. So it's not like a femur. A femur is a femur, like with a little bit of variation. Spine is actually a nightmare. It's good for me because I'm a researcher, so that's why I still have a job. Yeah, that's all. And so that's the normal spine. The problem, or the real life, is that we're aging. And as early as like 30-year-old, we're starting to see some change in the disc. And as we progress, or as we're aging, those change, like maybe it's going to affect the other part of the spine. For the vast majority of people, that's okay. You get old, like you don't move that much, like that's life. But there is a subgroup where those degenerative change become pathologic. And so I want you to think about spine issue as a systemic disease, in the sense that everything age is not just the spine. Look at this patient. Well, the spine is a little bit weird, but the patient already have like 2 knee replacement. We can assume that the muscle are going to be affected, like the hip are going to be affected. So we're already talking about, when we talk about aging spine, we're talking about aging body. And so we can say like, yeah, okay, that's not a big deal. But look at this number. So by 2050, so in the next like 50 years, we're going to have like 1.6 billion of people over 65-year-old. Basically, we're going to double the number. We did like some study in the past, like showing that over 65-year-old, you're starting to see the spine like collapse and deform, which means that in 25 years, we're talking about 600 to 800 like million of spine potentially with disease. So you can say, okay, that's not a big deal. But look at the number. When you compare this issue with other pathology, 13% of we're gonna have 13% of the worldwide population with spinal deformity or spine collapse. Only 8% of the population with diabetes, with 7% with heart condition. So it's really like a big problem. And those patients, it's not just they have a weird spine. This disease is associated with disability, loss of function. So it's really like worldwide, like a big problem. So we talk about like about the filter project. Like there is a very wide variability in terms of spine surgery. So first, there is some difference. Aging, you don't know, do you need the glasses? You don't need them? There's a large difference in variability in term of indication. And there's several reasons. Maybe as a clinician, you have a different philosophy of how to treat the patient. You have a different level of experience. The assessment of patient is also subjective. We can ask them to fill some questionnaire, but the way they describe their symptomatology, that's what you take into account as a physician. Same, we have a large variability in terms of surgical technique. Maybe it's based on your training. Maybe it's based on what you're good at. If you're good at with a specific technique, you're not gonna try like something new, like from one day to the other.
I think it's also due to the anatomy of the spine, because when you operate the hip, for example, you don't think to operate in the same time the knee or the shoulder. But when you operate one level to the spine, you still think about the level just above and just below. And this is the complete difference between the spine and the other specialty. I think it's the reflection and the thinking about at each level you treat. You have to think about the other level or the whole complete spine level.
Yeah, because basically everything that you do at one level will have some impact on the other level. Can be like positive impact, can be negative impact. No, we love the spine because we move, we do everything that we want, but then there's a cost to pay. Okay. The reality is that we don't have a universal guideline, and this is not a blaming game. This is not like come on guys, like you should all agree on what to do with the patient. There's a lot of variety for a reason. And this is almost like a joke. I was like, maybe the evidence, maybe the guideline exists in one of the 135,000 manuscripts that was published in the last 25 years. So we're getting like bombarded by publication. And at the same time, large variability in the way we treat patient. And this illustrates like maybe the disconnect. So that's also something that hopefully we will address with SpineDAO. Another challenge is a complication. So I took the extreme case, not the everyday case. I'm taking like the patient that have a totally deformed spine, like, the end of the spectrum. And this is some of the study that we did with the ISLG. So let me start to say that most of the time, surgery improves the life of the patient. I'm not here to blame surgery, but there is a cost to pay. One of the costs is a complication. If you take every complication together, including like the tiny one, it's about 70% of the patient will experience some form of complication in the very big surgery. And so we look at that because we're like, these are all data, from 2016. Maybe we're doing better now. Well, the reality, we're not doing better. So Renaud, that worked with me, same last name, published a study last year that showed at 2 years we have the same level of complication. By 30 days, almost 50% of those very complex spine will experience a complication. And by 2 years, about 20% of those patients will need another surgery within 2 years. The reality is that we are not very good at anticipating outcome. So we did a study last year with ICG surgeons. So very famous people that do a lot of academic research and this kind of stuff. So we gave them some vignette. The vignette include the demography of the patient, the past medical history, the clinical outcome, the detailed list of the surgery. We also give them the preoperative X-ray and the postoperative X-ray. The X-ray just after the surgery with all the measurement. And we ask them do you think that the patient within the next year will require an additional surgery for mechanical failure? So mechanical failure is something breaks. And this is what we got. So a few surgeons are pretty good. like surgeon 11, 17, like in terms of predicting who is going to be a surgical candidate within 1 year. Some of them, like, it's like only 35%. And again, that's because we don't necessarily have data. We don't necessarily have tools. It's very difficult to anticipate what will happen to this patient. So data-driven solution, that's why we're here. I would say some of them exist. You know, this is a publication from this around like the same topic. This is a joint work between like a US based study group and the European one. We put all data together. We asked like some smart AI people to develop an algorithm, and we can come up with a tool that predicts the likelihood of a complication. The industry, so our industry partner, they're also working on some data-driven tools. So Medtronic on the top, AlphaTech in the bottom. I'm totally conflicting because I'm a consultant for AlphaTech, but collectively they are developing tools to predict post-operative outcome. What's the problem? The problem is that for the academic world, they sit in a journal. So you have a fancy algorithm, you describe it, you publish it, and that's it. For the industry, their solution is kind of like dedicated for the user. So those solutions are really not readily available to you, to clinician, when you see patient. So what are the barriers to progress? We already talked about that, and Bruno is going to go into it to detail. Access to data is critical, and I will say like good data, not crappy data. Access to expertise, AI, software developer. We need to find a way to deploy those solutions, you know, because if they sit in a corner, like they're kind of useless, which means that we need to collaborate. And basically, that's the objective of the Decide project, to develop an algorithm to anticipate outcome. So we'll start with some basic data, but moving forward, maybe some automatic analysis, deep learning on the medical images. And we're going to need a lot of help. You know, we're going to need to engage the patient, because the patient are only like the owner of their own data. Maybe to engage some scientific society. Obviously, some clinical expert, both from a spine point of view, but from an imaging point of view. Some software developer, some AI expert, and as mentioned previously, like we need to question about like the regulatory aspect. Well, now you're going to do the smart part.
Yeah. So yes, we've been talking about a lot about what we need to do and what's the problem. But for me, the first thing that we need to consider is the data, because it's the key to leverage prediction. You can't do any prediction without good data, as we said, Virginie. Crappy data exists. This is everywhere, and good data is not common. So you need to standardize. First, you need to standardize the medical data, because it's very, very important. And as you said, there is no consensus on medicine, what to do and what not to do. And on data, there is also a lot of different standards, different solution that offers different way of putting on the data. So that's the first problem is to have a standardized data. Then there is the source of data, because the patient is the main source of data. But to predict the best surgery, the doctors, they own the rest of it, because they know they will see stuff that the patient can't see when they are doing the surgery and when they are seeing the patient. So that's 2 points of view that you have to put together to have a good data. And the last part is the labeling the data prediction, because you need to interpret the data and know what, try to label. As you said, there is a lack of consensus, but you have to label it to be able to interpret to predict. So yeah, the predictive algorithm, I will not get into details of what a predictive algorithm is, and we will talk about it a little bit further this afternoon with my colleague Jean-Jacques. But just to put a little bit of context, predicting the best surgery is not easy, because it's a complex task. First, it's not just saying, let's just say a classification, something very simple. It's not just saying, is right or wrong. It's something that is evolving in time. So you have the pre-operative data from the patient, which is heterogeneous. You're gonna have the data that will come just before the surgery, but you can go all the way up to the patient being born, because everything will influence prediction that you will put. And for that, we have a lot of tools that now everybody has heard about deep learning or AI models. Very, very. It's a big buzzword at the moment. But in the last 10 years, it's been making a lot of progress. We started with artificial neural networks back in the 90s, something like that, and now it's evolving very rapidly to generative adversarial networks, where the height 5 years ago, and now we are on to LLMs. So the technologies are evolving very fast, and we are at the point that we can use those technologies, which are far better now than 10 years ago, to do better prediction on the evolving of the patient. And as I said, the prediction of the best surgery is based on the supposed outcome, because you're supposing that the patient is gonna do better or worse. But it's not static, because the health of the patient will evolve. As you said, Guillaume, a surgery on a level will influence the other levels, but a surgery on the patient will influence a lot on this way of life, and then the way of life will put a toll on the results of your surgery. So now that we know that there is tools, there are tools, predictive algorithms, and we have good data, then to turn data into predictions fairly simple. I'll say first you need to label the data, so you have to have a consensus, as we said. Then you select the model. That's the worst part, because you have a lot of models that you can choose from. When you have that, you can start training the algorithm. And so the training, so you take your data, you split it in two. So first you have the training data set, and then you have the test data set to validate your model. And when you have done that, hopefully you have a model that is, you have a response from the model that is good for the problem that you are considering. Sometimes you will have to go back to the first step and do it again and again and again to find the best fit for your model, for the response, for the answer that you want. And then when you have that, you can start testing it in real life and validate the accuracy. And that's when the big part is about legal and compliance, because you have to be compliant with the marking list in Europe, for example, the European marking, if you want to be able to test it in real life with the patients. I'll just go into small anticipated challenges that we can pinpoint. First, you have to build a meaningful tool for the surgeon, because, as you said, there is no consensus with the surgeon. So let's say that you have built a tool that is good for one surgeon, might not be the best for another surgeon. So you have to find the best tool. And so it might need to be adapted for each surgeon, maybe not surgeon, but region of the world, because somebody will have different practice. So you need for that, you need to collaborate with surgeon for the design, and also the patients, because if you don't have the data from the patient, then you don't have anything. So you have to put the patient first to get the data, and then you can. So then that's one of the big challenge. Then you have the data gathering and standardization. So you have to master the data that you are collecting, and you have to know where it comes from. Is it a good source? Is it a bad source? What can you do with it? So again, patients need to be part of that journey. The last step is the thing that is the most concerning when you start doing a algorithm in the medical field. You have to apply to legal and compliance. That's a big part. We're going to talk about that this afternoon with Jacques. Predicting the best surgery for patients is not like any other prediction. We have heard a lot about ChatGPT, DeepSeek, and all that. Those models, they do prediction, they do stuff that it's AI, but there is no compliance or legal requirement behind, except from the GDPR. But we know that's their main concern sometimes. So when you are dealing with medical data, you have to be very precise on what you do, and the legal and compliance is very, very tall. And it has to be tested and documented. So you have to have medical study to back up what you were saying. So there is more challenges, but that's just a part of it. And maybe you want to finish.
Yep. So the good news is that we already have some partnership. So either established partnership or people that we're dating. So as you know, we're being supported by Bio, and this is huge, because we have so much to learn in this side. We also have a partnership with Data Lake, and they're going to do a presentation later. So Data Lake is going to help us at least at 2 levels. We'll see, maybe more. The first one is to engage patient. They have a way to for the patient to sign some online consult form. And this is pretty cool because the patient actually will be able to choose which project they want to participate. So it's not a blank consult form, They're going to be able this project I agree, this one I don't really want. Data Lake is also going to help us in terms of data management, that in the name, data storage for us to be compliant. And in the room we have so much expertise. So Artifacts that is hosting us today. That is
General AI expert.
Okay, general AI expert. Contact from Bruno that have some experience in terms of developing some algorithm dedicated to the medical field. Follow, which is a solution that a lot of surgeons here are using. That's an everyday solution to document your patient and also to do research. And a few of us are part of some study group, and we'll see. Maybe there's going to be a point where we want to partner with a study group and develop some solution. So if you're interested in joining us, in helping us, you're more than welcome. I also want to set up expectation. So all those tools that we talk about, for now, they just need to be better than nothing. Because right now we have nothing. So we don't need to solve 100% of the problem. We're going to start small and incremental improvement. Thank you.
Yeah, step by step. So now that we have this kind of this side project that we don't have a real roadmap because it's quite difficult to gathering patient data from baseline to 2-year follow-up after surgery. And I hope that Steven from Follow can have an insight on that with his presentation this afternoon. Some question, Alex?
Yeah, I'm wondering, in the future, right? Long-term future, can we imagine this side actually playing a role with robotics in surgery?
Absolutely.
Yeah.
Yeah, and that's why I talk about two companies that I know in the field of spine. So they're developing some solution right now. It's at the pre-op level, but the point is to drive intraoperative technology. So within spine surgery, there is already some solution, some robotic surgery. They're starting to also to develop some virtual reality or augmented reality. We're still at the beginning. So those solutions exist. I don't want you to think about the fact that every surgeon is using some fancy tool. There is still the vast majority of spine surgery is done with a hammer and a mallet. Those solutions are starting to emerge. And so if we're able to anticipate some outcome, then maybe we will be able to provide some input to those technology.
Absolutely.
Do you want to say something? I know you're quite involved in
Transparently, in the span research community, we have a project and the robotic led by a smart surgeon, Antoine Genari from Nice. We work in Montreal in the side books. There is a group that are working robotic projects.
Okay. Yeah. And I think that's where the principle of DAO is a collaboration. So as I say, we don't need to do everything ourselves. If we develop a tool that is able to anticipate some of the outcome, then we need to partner with companies that work in the intraoperative field. And that's really key. We need to know what our own expertise versus where we don't have to do anything. We accept partnering.
Absolutely. Okay.
We obviously know that we need good data to do good science and the project like this one. But at the same time, we need to protect patient privacy. What's your take on that? How can we have like open data and still have patient protection?
So I think that two things. So first, we're partnering with data lake. That's what they do, and we have to differentiate like open data in the sense that people usually think about like open access versus like open use of the data. And in the sense like, and there is a few technology. That's not my expertise, but you can develop some algorithm without ever like hosting the data. So that, and we're probably gonna have some talk in the afternoon. Like you can even have the data sitting on different server or sitting in different regional entities, and based on that develop some tools. So we don't necessarily aim to be like to have ownership of the data. We just want to be able to access some of the data.
Yeah.
Because at the end, like, you know, when you come to data ownership, like everybody is pretending that this is my data. So the surgeons are like, this is my patient, so it's my data. The hospital is like, you're seeing the patient in my hospital. I'm the owner of the data. The reality, like the only thing that we know is that the patient has ownership of data. And that's really like where we want to focus, is like to put the patient at the center of this project. It's going to be like critical, not only to access data, but also to get feedback from the patient, because we tend like to have a picture of like, that's what we want. That doesn't matter like for all the shareholders. So there is a clinician, there is an industry, there is a patient. That's critical.
And the aim is not to put the raw data in blockchain. You have to be aware of that, because it's technically super difficult. It's super expensive, and it's also not super efficient. What we want to do is to labelize and to create metadata from the data, put human expertise in order to train the model. And all this action has to be in the blockchain to ensure transparency. But the raw data, we have to think about how do we do. Maybe we take the data, we just labelize it, and then we come from a knowledge with knowledge graph, and then we train the AI agent, and then we just send it back to the patient. So it's useful to practice out.
I think in the DISA ecosystem, we used to talk about data unions for patients, where that's a bullshit.
Yeah,
I think that Wojciech will have a super insight on that at the end of the morning.
So we don't have like a firm answer to your question, and that's not necessarily our expertise. So that's why we're partnering with people that know like
Let's on board. Okay, and coming back for the execution stuff, and then we jump on Tracker project. Yeah, the execution is super important. I mean, for until now, the execution of the surgery is made by human. Even when you talk about robotics, well, it's not the robot that really saves the surgery. When you see that the multi-arms or robotics, it's mainly on digestive and urology. There is a human being behind the machine that is playing with the joystick. So surgical execution, it's a human praxis, and it's an exclusive human praxis for the moment. So for a robot to learn about where I go for my neurologic decompression, I remove some bone to decompress the nerve. But when I know that the nerve is decompressed, to have a learning process on the machine, we take some time. And maybe Maxime could talk about that like later on solution about like inside vision of the surgeon, and having this images on the robot to learn about the human practice. Okay. Yes, I think it's time for Tracker project.
So we prepare to start with transfer. Maybe or SpineDAO prefer, because for Tracker we need more time. As you want, SpineDAO or maybe.
Okay, you want to switch the program? Okay, no problem. So yeah,
I'm back.
let's go Virginie for this Spine journal, and unfortunately Bertrand is not here, but Bertrand de Bono is a neurosurgeon in Versailles. I'm pretty sure that he's on the YouTube live. I mean, this is the part that I love in SpineDAO. Being on research projects, training predictive model, it's not so much for me. It's more on Guillaume expertise with Bruno, with all that super team, and I'm more on publishing. And we will talk about the Spine journal. Maybe after we'll check Nassim to speak about Spine archive. So yeah. All this analysis from research project to be understandable for everybody, from the super expert like the spine surgeon that is interested in techniques, but also for the patient. And I know that when a patient knows his damage, when you are in the office and you explain the damage to the patient, it is 50% of the cure, because he knows his damage, he sees his damage on the MRI, and say, yeah, this is my pain generator. It's not in my head.
Hey man, how's it going? Oh, great. I just had a paper published.
Yeah.
Yeah. And this is quite a good introduction for this Spine journal.
Yep.
Yeah, let's go. Just to explain what we think this side is very important. This is a...
Hey man, how's it going? Oh, great. I just had a paper published. Dude, congrats. That's awesome. It was in a pretty prestigious journal, too. Oh, wow. They probably pay you pretty well for that. Yeah. Wait, what? The journal. They published your paper. They must have paid you pretty well for it, right? Oh, well, no, the journal doesn't pay you any money. Yeah, but they're using your paper. Yeah, so... Well, like if you spent years writing a book, you sell the book, you get money for it. Oh, well, I do get paid to do the research. You know, I get grant funding. Oh, so the journal that publishes your paper, they give you grant money to actually do the research. No, the grant money comes from the government. So the journal doesn't pay for the research or the content that they're publishing. Are they some kind of nonprofit? Oh, no. The largest academic publishing companies make like $20 billion a year. Really? Yeah. Their profit margins are like 40%, which is higher than Google. So why don't they pay you to publish your paper? Well, I get something much more valuable than money. What? Prestige. Well, why can't you have both? Because it's not about the money.
I think this is the better introduction to explain why we have to move. Because we chosen already done that, and we certainly agree 100%. That's the main session.
Thank you. I need a bucket, but I'm a PC person.
Let's go.
So as Vincent said, unfortunately, Bertrand cannot be with us. He's busy with patient. And so...
What? It's still got what?
Yeah, he's working on it. And so he put this presentation together. So we got like the evolution of academia over time. So first, people were just publishing and very happy with that. Then, the concept of like publish or perish. That's what we learn when you start to do research. Then publish in high impact journal or perish. Then publish frequently and maybe you won't perish. And so there is this paper that was published not too long ago that the first, I learned by reading this paper that the first journal was designed in 350 years ago. So we don't want to think we're like super like doing like some new stuff. Like this is like this is the longest story. In this paper, you also realize that when you come to medicine and all those fields, like 50% of the publication come from the 4 biggest like publishers. So what are the pain points in science? We all know about that. So you need to find funding. There's a question of like ownership. Who is owning like the data? Who is owning like the research of the data? Most of the time, there's going to be like the institution you're working for. Publishing, I'm going to go back to that later. Data management, access to data. So it's quite complex. What are the challenges in terms of traditional publishing? First, there is a cost. Most of the publication on journals, they're behind like a paywall. That means that if you want to access like the knowledge, somebody has to pay for it. Publication takes forever. Even in Spine, sometimes it takes like up to 1 year to get your paper published. And that's not like the only issue. Like once the paper is published, it's already old. Because let's say like you first have to collect data. You put your protocol together, you're starting to collect data, you need to have follow-up on those patients. So it's already like 3 to 5 years by the time you write the manuscript. Maybe you procrastinate a little bit writing your manuscript, so you had 1 more year. Then you send your manuscript, it gets rejected, you change it a little bit, it gets accepted. Then you wait, and then you get published. As I mentioned, there is limited accessibility. There is also like a lack of transparency. Like if you ever publish a paper and you receive like some feedback from the reviewer, first you're not even sure that the reviewer is an expert in the field. I'm being asked sometimes to review paper in OBGY, and I'm like, no, not my expertise. So it's quite difficult, like to find some reviewer. Maybe one of the reasons is that you do that, it's an extra amount of work. So you do that like maybe at night or during the weekend. That's not necessarily part of your job description. And sometimes you receive a review that say, good job. So positive review.
Yes.
That's it, like 2 words. The worst is like when you receive one, which is 1 word, rejected. So I'm a reviewer for a bunch of journals, and I do complain once in a while. And actually complain like to the editor, because my co-reviewer, they're like, they write 1 line. This is not a review. This is like, I had a look, I don't like it. Or I had a look and I probably know who is submitting the paper, I'm going to accept it. So this is not only like a well-designed process. And the content is very static. And I will talk about this later. So these are the costs of accessing either one journal that you can rent, like on Netflix, or you can rent a film, you can rent a journal, or you can subscribe. This was a cost in 1992. Yeah. Let's check like the new cost. So let's say you're doing a very, very fancy research, good enough to be published in Nature. And you're like, I got a paper in Nature. I want everybody to have access to it. So then you choose the option like open access, which is totally feasible as long as you're willing like to pay $1,200,000. This is crazy. Like you spend like a year doing your research, you get it published, and then you have the choice like, okay, nobody's going to have access to my journal, or I put my credit card. The reality is like most of the time the institutions are paying for that. And if you're fortunate to be in a big institution, you may have free access to the journal. But that's not universal. Going from Nature to the Spine journal, different level. Still $5,000. This is crazy. And this was sent like to our Discord. I'm learning Discord is like a different week, I'm lost, I'm like stressed about Discord. This is, if you take like the most common, like the biggest publishing company, look at how much they receive between 2019 and 2023, how much money they receive based on people wanting to have the article in open access. Almost 9 billion. So it's a pretty good business. So I'm a publisher. I'm going to ask like, okay, the researcher, like, doing your work, okay, you get the salary from your institution, but we're going to publish and without give you anything. In the meantime, like, find some reviewer, pressure them so that they do the review. And then if you want people to read a paper, just pay for it. And altogether, like, let's say in 2023, 2.5 billion. It's quite interesting. And this was mentioned in the video. So if you look at like the biggest publisher, it's a 19 billion industry, profit margin 40%, which is more than Facebook, Microsoft, Zoom, Coca-Cola, why not? Alphabet. And this is a side note, like when you come to biomedical and life science, there is 30,000 journals. So some people like find some solution, this is a totally illegal, but if you wanna find an article and you don't want to pay with it, like can go on side up, put like the DOI, put some information, get the paper. And so that's nice, like for everybody that want to have access to science, but then obviously like the big publishers are not super happy about it. And once in a while they sue them. As I mentioned previously, like the process is very long due to the reviewer process, due to the fact that you need to wait for your paper to be published. Maybe you get some feedback that you have to change your paper. Maybe you get rejected, so you start again the process like from the beginning. And so this needs to change, and we're not the first one to say that. We need a solution where you have access to finding like in a way faster way. We need a solution that is transparent. The reviewer, like who's commenting on your paper. Because we all think that we're super smart and our paper is the best in the world. But what if we collect feedback along the way from the community? At the end, we're going to have a much better paper. We want to push for dynamic content. And we have a video about that. And so the DeSci world that I discovered just a few months ago, thanks to Vincent, or maybe because of Vincent. Yeah. And I want you to think it's like with the first one, far from that. There are already like a bunch of tools. There is already like a bunch of players that can help us like along the way. And already like the key point is like we want a process that permit to transparency, accessibility, and also we want to incentivize people. That's only fair. So this is like a summary of the difference between like traditional journal and DeSpine or DeSci journal. So open access versus paywall, transparent and decentralized versus slow and opaque. Some incentive, the fact that you can update the content, and very like low cost or community funded. We have to be realistic. It's not traditional publishing versus DeSci publishing. Those two have to be complementary because we also live in a world where we need to have our paper publishing in PubMed. I know in science you get some funding if you publish. If you want your academic career like to advance, to go from associate researcher to maybe associate professor or full professor, you need to show your impact factor. And so we want to develop something that is complementary. So with Bruno, we put this video together. So you will go like from a PDF to something that is way more dynamic, something where you can upload some video, something where you can interact with the graph. Let's say you have a study that show, I don't know, complication after a given type of surgery. Then maybe you run the graph and you say, now I want to see the patient from the same paper that are over 50 years old. Does it change? Maybe a solution where people can upload their data. Because if you upload your data, somebody else can run the same analysis and tell you, you made a mistake, or yes, I confirm. So we want to go way beyond like the classic way of publishing data. I'm going to sound like a broken record, but for that, like we need a partnership and collaboration, because there are some existing players in the field, and we don't need to reinvent like anything. Now, probably the biggest player today is a Research Hub. So Research Hub does a few things. It can serve as a preprint server. But what is super nice about it is like, as a reviewer, you can sign up, say like, yeah, I'm going to review this paper. You have to do a good job. Like a crappy review are not going to be accepted. And if you do a good job, you get rewarded. As an author, if your paper is recognized or several papers are going to be like recognized, then you are starting to be recognized as a person, as an expert in the field. So there is this incentivization, both from a reviewer, but also the person that submit the paper. And so this is like the overall advantage. Like you can have everything in one place, your manuscript, your data, your code. Why not? If you develop an algorithm, you want to give it to the community. You can have some visibility with a badge system, and you can still publish in traditional journal. So we already talked about this, so I want to move a little bit forward. What about later on, like combining this with some AI-based like research solution? I mean, look at like how boring each of the introduction of our paper are. You always start by, this pathology is complex. First paragraph. By the way, other people look at that, but they didn't do a good job. And we're going to save the world. What if all this part, like the context, is automatically generated? Because that's not necessarily the core for research. The core for research is like, the methodology and the result. So once we up and running, I'm going to invite like everybody like to submit your research. Let's not call that a paper. Become a reviewer, or right from the beginning, you can get involved as a contributor. Take it.
Yes, I think also we have to think about this spine journal for the patient also. Maybe if we democratize it very, very well, the patient could be interesting to read some article like that.
Yeah. So the way I envision is like, you get some feedback maybe from a preprint like Research Hub. Based on this feedback, you generate like a very good paper that gets submitted to traditional journal. And then you have another path, which is a dynamic content, which we can develop at different level. It could be like for researcher, it could be like for patient. So it's basically the same message in term of finding, but adjusted to the audience.
Yeah, sure. And coming back from the reviewer, I mean, what will the value of the review? I mean, if they can get some token to have like a good reviews, and you want to put a guideline for the reviewer?
So that's what a researcher is doing. So if you want to review papers, they give you a guideline of like what you need to review, like in a very methodical way. And if the community thinks that, I believe that the process, like if your review is being organized as being a good one, then you get a reward.
Yeah. So there is like a reputation system on the review.
There is a reputation both from a reviewer point of view and from the researcher point of view.
At that time, you still have to pay to publish a research journal. They just create a research journal, and we have to pay and try to publish something 1 week ago. But at that time, we still have to pay in the research. I think we have to think about that if we decide or not we want that the researcher has to pay, or just the reader, or nobody maybe. But it's important way also. It's nice to reward the reviewer, but it could be nice also to.
The researcher has to be rewarded for it as well.
But then it depends is the number of the reader also. It's like a book. Your book, you don't sell it. You don't have some money.
That's a good point. If nobody reads your research, then like, come on, it's accessible. Nobody read it. Like,
Yes.
as Vincent will say, like, do it again.
One spine token by the way.
Yeah. Yes. I have a question. Have you heard about decentralized, which is like an open source tokenized platform to publish metadata? And I think it's raising the question now because, like, I think if I'm not mistaken, decentralized is actually like, okay, you get published, you can have peer reviews, everything is tokenized, okay. But then, like, they don't have any, like, specialized, like, journal within their, like, open source platform. Do you think we still need to have, like, specialized journals in order to have, like, okay, even if it's open source, even if you don't pay, I think there is still something like this game of, like, oh, I publish in, like, Nature, like the open source Nature, right? Platform. Is it something? Do we still need those, like, journal labels, I would say?
No, I'm not sure.
Okay.
I'm not sure because first, in terms of categorizing, like, your research, that can be done automatically based on the content. And then instead of having, like, your article under, like, a given umbrella that is more prestigious than the other one, I don't know. Maybe it's going to be more this specific article that pop up as being, like, valuable.
But it's like peer review likes.
Yeah. The honest answer is, like, I don't know yet.
No, I'm like,
Yeah.
bringing this question.
Maybe you can imagine if the platform before traditional science, if the paper is with a lot, and if we have more than, for example, 10,000 readers, that give us some money, and this money give the opportunity to submit to open access, for example, international.
Yeah, and I think, like, we will get some advice, and we can check, like, what the other, like, decide publication are doing. Right now, I believe, like, what we need to focus on is, like, this concept of, like, I'm still going to publish in traditional journal, but I want something dynamic. It's super boring to read a paper.
Sure.
Like, super boring to read a PDF. And then once we have something like that is kind of like attractive, and then we think about, like, the reward system, and, like,
we can.
I'm like, I want everything to be free for everybody, so I'm not the right person to ask this question.
We will have a tokenomics for that, but we can dream, and we must dream about, like, a system. When we publish a research analysis, it's also for the patient. Like, yeah, we compare two surgical techniques for degenerative spondylolisthesis. Let's explain to the patient what is spondylolisthesis, degenerative spondylolisthesis. Let's explain what is a posterior fusion. Let's explain what is an anterior fusion. Let's explain that we analyze and we compare the outcome from the two techniques in this spine damage, in this specific spine damage, and let's adapt to every cognitive system and explain to every cognitive system.
Yeah, and this project is going to work, like, hand in hand with a spine archive that will be presented later. Like,
Oh yeah.
Could we imagine a robot just read all the paper and create a video? Because at that time we have visual abstract, but we create a visual video to explain all of the paper.
Absolutely.
Yeah.
We can think about, and we speak about that with Nancy and Pascal. So we will speak about that with Nancy. There is, like, almost 30 articles on spine surgery every day. Let's put an AI agent feeding by this article, and every month we propose a digest in video or what are the last discovery on spine surgery or on spine care in general, and let's make a digest with AI agent with AI creative product. Super fascinating. Wow. Okay, let's move on. So, what you want to do? Can we do upload it for Pascal because we are here? Yeah. Thank you so much. So Pascal Kebia is the head of Artifacts. Thank you so much for hosting this event. We will have some artifact insight on with Suman this afternoon probably. Yeah, absolutely. Yes, we be and we are quite on time. Should we have 2 to 3 minutes time? But usually we'll explain the window. Super bad.
Thank you very much. Thank you. I'm François Charan. I'm a French neurosurgeon working in Italy and in San Marino. Thank you for the invitation and thank you for letting me be part of the project. With this project, I will present you the SpineX. So don't see any parallel with some space program or something like that. Nothing to see.
We hope that we have the lunch that discussed.
So we will talk about educating patients, and educating the spine practitioner, the surgeon, the pain therapist, physiotherapist, and etc. As you saw, the SpineDAO is an open collaborative work with giving accessibility to data, transparency, etc. But at the end, as said Virginie, we are still craftsmen. So we are working with the hammer, with rods and screws and endoscopes, whatever. So you need a good brain to be at the link of the chain. So the final link of the chain to apply it with the ends, the good protocols, the good recommendation we want to do. And as you saw, spine surgery, spine practice has a lot of failure, of complication, because we are dealing with our hands and there are lack of skills, lack of technical skills, lack of non-technical skills that can lead to failure and complication. In other fields like the aeronautic or military or the astronomic field, they are much better trained and they are applying process of learning, practicing before piloting the first aircraft. In surgery, you can operate a first patient without having done never before. So this is pretty high difference. Of course, the pilot has 300 passengers, but the surgeons still have one, at least at the time. So there are well-known processes.
The other difference is we are not on the plane. If the plane crashes,
well, we have the parachute.
Yeah,
we have the parachute. No, I did crash the plane. I can fall exactly. And this famous Dunning-Kruger effect, which is very known in many other fields, but in surgery is not very well experienced. Is important to know that experience with training is mandatory. And there is something said that we should never do the first time on a patient, but actually it's always like that. The first screw was on the patient, or the first endoscopic procedure was on the patient, and there is a lack of before. And then another point which is important is that the patient are not well informed. They don't know what they are going to have. If it's a pain therapy, physical therapy, surgery, they will, okay, I will follow your advice, but I don't know what I'm going to through. And so the patient should be active and an actor of his treatment. So we would like to decentralize the education of patients and surgeons and surgeon practitioner in spine field to get better outcomes. And this is the objective will be to train and educate surgeons wherever they are, whatever the place they are. And so this is to bridge the gap in between the research and the clinical practice, as said Virginie before. There is science, there are data, publication, but to apply it on the patient, with a physical therapy or pain therapy or surgery, it's another work.
That's it.
So the objective is to develop a digital platform with tools, programs driven by AI, and not because there is another point, which is a lack of transparency and a lack of interest. There are a lot of conflict and interest in education. You will be educated by an industrial, you will be educated by a distributor, you will be educated by interested people. So it's not a good process to train on a technique. So you will see in the afternoon some platform to educate the patient, some simulators physically or in augmented reality or virtual reality, until the last training possible, the avatar, to train on patient, on virtual patient before training on the patient, on the real patient. And all of this is to enhance the comprehension of the patient, the comprehension of the surgeon, of what he is doing, and to let the patient be active of his treatment.
Just to show a quick cartoon that we already create to this is a way that we educate the patient. I'm just one. Maybe there is a problem, but we already create some. Maybe Vincent can introduce the cartoon.
Yeah, sure. So Karim is performing a cartoon powered by AI to explain to the patient the disease, also the prognosis of the disease, and the different therapeutic alternatives. So what's created like some character like the patient, a doctor spine that is saying the disease, but also the disc, the nerve that are like character in the cartoon. So the nerve is compressed by the disc. The nerve say, "Oh, I'm compressed," so I send the message to the brain, and the message is the sciatica, the pain, and the patient have the pain, and then we explain what kind of prognosis is it. Like you have to know like 80 to 90% of the disease resolves itself, and for 10% it doesn't resolve and would lead to a surgery. So just patient educational cartoon program. I think it could help people to have a more better understanding of their disease, but also of the prognosis, the risk and the complication of the treatment, because it's a significant part of the office hour to explain and to have a patient that's already aware of what you have, so you can go like deep inside is a tailor-made product. So that's the objective of the patient cartooning educational program.
And the patient has to be informed like the passenger of an aircraft. You have to know the safety procedure before starting to fly it. And in surgery, it's pretty random. So in the afternoon, you will see 3 medtechs that are working on education of patient and surgeon or practitioner in spine care. You will have Maxime Ross from Kairos Medica, Federico Nicolosi from Upsurgeon, and Nicolas Mignon, I don't know, probably from Virtual Research. There are very different platform on simulation and education. So the objective of SpineX projects is to get a platform where we can get education for both surgeon and patient. To change, of course, the future of care. As I said, this is the final link of the chain that links the research and everything you saw before with the clinical practice, that for the moment we are not driven by a robot, so we are still using our hands. So we have to, I talk about technical skills, but of course all of the decision-making algorithm are parts of the training project. The surgeon has to know it's in each situation if he has to choose the right way or the left way, and this is something done already in aeronautic, but not in surgery. It's only experience, and it's very experience. It's not, and this is it. Thank you.
Thank you so much. Yeah, let's move now on Spine Arcade. To be honest, my favorite project. There was a question? No.
Yes, I think you are on the...
Perfect, Nassim is on air.
On the screen, Nassim, if you want to talk, then I think we hear you.
Hello, everyone.
Yes,
Yeah, you hear me well?
Yes, perfect.
Yeah, super.
All right, perfect.
So this is the first partnership.
Apologies for not being able to be there. I hope you're having a good time. I've been calling the stream. So let me open my slides and share my screen.
Do you hear us, Nassim?
Yes, I do. Perfectly.
Okay, perfect. So I'm super proud of this partnership because it's the first partnership, official partnership with SpineDAO. Nassim is the founder of Preprints. And to be honest, it's my favorite topic on SpineDAO. That's basically why I'm doing SpineDAO, is Spine Archive. So let's put the magic, Nassim. Let's perform what you wrote.
All right, so the Spine Archive is also something very exciting for us, for Preprints. Just a few words about me. I'm a computer scientist, founder of Preprints, High Labs, and we do mainly publishing on the blockchain. So we publish preprints directly on chain, and we also have a few AI tools to retrieve information from the knowledge base that is published, as well as help researchers in general. And so with this project, in which Vincent also involved the Académie Nationale de Chirurgie, with his charisma, he could get them, and we're also very excited with this partnership. I think it's a first for this site to have an institution this old and this prestigious. And so the objective is fourfold, in fact, but overall it's to culminate in creating an AI agent that will know all there is to know about some area of science. So initially our goal was to do it for the whole spine health field, but we revised our ambition to be a little more targeted. We want to build agents that have depth within some subfields of spine research. And besides that, and the basis for these agents would be the world's most comprehensive spine health knowledge ecosystem. So it would include preserving historical manuscripts and also aggregating and compiling all the research that is published and that is always incomplete in indices, as we'll see. So we have 4 objectives with this project. Now, why does it matter? There have been a few papers that have studied this. There are hundreds of journals that disappear every year from the internet, and they are no longer accessible. You can read about it in this Nature article. And also the DOI system for preserving manuscripts, which is its stated job, doesn't work that well. And we think that blockchain could be a better solution. And why does it matter specifically for spine health? Well, it's because the human body doesn't change much, in the few thousands of years that spine research has been around. And it's very common. I've found several instances of this, and Vincent and other specialists can confirm this. It's very common for modern contemporary doctors to be inspired by historical texts. For example, there was this very interesting documentary from the Mayo Clinic about a researcher that could solve a case based on a 60-year-old paper. And there are also many people who are inspired by even publications from antiquity, including Hippocrates and the fathers of spine health. So it is very important to preserve this knowledge. Now, as I was saying, we have 4 objectives with this project. The first one, and the basis of everything else, would be to preserve historical manuscripts. And this is where the partnership with the Academy would be important. So we'll have access to all their historical texts through the library. And our job would be to digitize them through OCR, optical character recognition, to build a knowledge base that is accessible for future AIs that would be our assistants for research, as well as future generations of humans. Now, this will serve as a basis for a second component, which is to build, really our objective is to be exhaustive, an index that would cover all of the published spine research. And so that includes modern indices like OpenAlex or PubMed, which are incomplete each in their own right. So they each have papers that don't appear in the others. So I think an organization like SpineDAO is very indicated to aggregate and compile this knowledge. So from modern indices, and then we'll augment it with these preserved manuscripts that can go back, hundreds of years. And then once this is done, and in parallel, in fact, to this, we're also going to build a knowledge base of, the compiled research, beginning with subspecialties of spine surgery and healthcare. And that will be based on, knowledge graphs or semantic networks, as they're called, that will first, embed this knowledge in a way that is readable by AIs, and also find commonalities and common, links between these knowledge graphs. And that could build, again, depth within some area of spinal. And then this, as I was saying, will accumulate in AI spine agents. On the one hand, we'll have specialized agents that have depth, for example, in adult, spinal deformity, or some subfield that I'm learning about myself as a non-specialist, and also breadth of knowledge. They would have access to, embeddings of general knowledge about spine health, and also to other agents that they can communicate with and collaborate. So this is the plan in four steps. Just a few more details about preservation, for example. We have already started doing it as a test with the library of the Academy. So how does this relate to a DAO, and why is a DAO needed? I think a very interesting thing here is that we could incentivize the submission of, hidden gems, and also corrections to our existing, database with Spine, the future currency of the DAO. So there would be collaboration between humans and machines on this. And another important point we want to emphasize is that we're going to use decentralized storage, things like RWE or other providers of decentralized storage, and also have redundancy, so that we maximize our chances to preserve this knowledge for future generations. So here's an example of what we have done for this manuscript in Latin. The tech works very well for languages like Latin, Arabic. Some manuscripts are in these languages in the Academy. So this would be very useful as a primary step to preserve these manuscripts. And so if it works for these ancient languages, it's most likely going to work very well for English and other modern languages. And so once we have this, we're going to integrate it with our index. We have a prototype for the index, which is right now, fed manuscripts from modern services like OpenAlex or PubMed. And again, each one of them has its own lacuna and its own limitations. So just aggregating, the various services that exist out there and specializing them in spine research would be valuable. So spine researchers can access, for example, all the latest manuscripts published in the field here. And Vincent has some interesting project to build a sort of podcast and, daily news about the latest research based on this. And then also find, for example, specific papers on some specialty or conditions such as hernia. Okay. So this is easy to do. It's modern libraries and indices, and we would augment it with our preservation effort, and also with the incentives that exist for participants in the DAO to submit their own papers, and researchers, for example, to submit their private libraries, etc. So again, we're aiming to build as exhaustive as possible an index of all spine research.
Yeah, just pause on that. Imagine a chat GPT specialized on spine. Like, you want to know the first description of a spondylolisthesis, of our hernia, or of our fixation. And with machine technology, the chat GPT will be able to provide the exact paragraph that was written like 200 years ago. For example, for spondylolisthesis, it was written by a Belgium gynecologist that couldn't take the baby of the woman's belly because of the severity of the slippery of the vertebra, and he discovers this disease, and he just describes the disease, but it's in a very old book that's totally hidden, and I was able to find this gem. So imagine if we, and Dassim will explain how to digitize this letter from the OCR. But imagine asking the ChatGPT to tell you the story. We need to know where we're coming from. So the technology will be able to do the repository, but also to expand this knowledge and to put this treasure out of their box. And just to emphasize on Academia Nationale de Chirurgie, so they have in their library 900 manuscripts that are not digitized already, and they are struggling with public funds. So with the DAO and with the help of all the contributor and investor and token holder, we'll be able to incentivize them. Like we come to the Académie Nationale de Chirurgie, we go and see Guillaume Pourchet, the librarian. We digitize the manuscript, and for each manuscript, we give Spine token to the French National Surgery Academy. It's a way to enter the Academy on the Web3. So the Academy has to have a Web3 wallet. The Academy has to deal with Ethereum and all these things. And it's very interesting for them to go out of the public fund, because we can also do that on like other specialty of medicine and surgery. And that's one of the goals. Thank you, Nassim. Sorry to interrupt.
It was actually very interesting, complementary to what I was saying, especially the fact that, and I discovered this myself through SpineDAO, the field is one where anecdotes matter. As you have mentioned, a baby, a specific case can inform someone 200 years later. So I think it's really unique and very important to preserve this. And so the next step, once we have this exhaustive index, there are already more than 4 million articles that we cover in our index here, this prototype. So these are modern articles from services like PubMed, but we hope to be able to add at least a few tens of thousands of rare gems like this. And then comes the knowledge engineering step. And again, all these aspects will be done somehow in parallel. So we're already doing it for some of the papers we have. I'll show up an example later. And here it will be about first embedding and creating vector databases for all this knowledge that can be read and understood by AIs. So we do that for general knowledge. All the papers in the index will be embedded. And for specialized knowledge, to create depth within sub-disciplines, we'll also create semantic networks, also known as knowledge graphs. And so we have an example of this with one of the very prestigious papers published by the core team in The Lancet. So we have started doing it to show you an example of the kind of knowledge graphs you can get from, this is just one paper. So it is about adult spinal deformity. It is going to identify within the paper all the entities that matter. This could be, for example, a diagnosis, a technique, or some symptoms, and also types of relationships that exist between them. And then here is what one paper can produce. So the central topic is adult spinal deformity. We find that it is associated with sleep disorder, depression, also other types of relationships about what it can be diagnosed by, the techniques, etc. And again, this is one paper. For me, I mean, this kind of networks are not supposed to be human readable. They are not supposed to be for us, but for machines. So they'll be very useful to build, the backbone without ton of the agents. Once we build, networks like this for all the specialized papers, and we also link them to common, entities and relationships, but possibly for even humans, myself, again, as a complete layman in the field, I found this network very useful to understand what Virginie and other authors, Bassel and everyone else is about. So
Nassim, again,
this could also be useful.
It's super important because it's a part of the entire PDF. publishing system. We want to publish something dynamic. And when you see this kind of picture, you can understand that Hadoop spine deformity is not only a matter of radio geometry. It's not geometry in the X-ray. It's sleep. It's also disability, performance, emotional issues. So it's a total multidisciplinary approach. And also this kind of graph is super cool because it illustrates the necessity of building bridges between the specialities. So yes, and you show the OCR technique. Yeah,
right. So
it's super important because we want also to be like the Alexandria library, to be the world repository of spine science, and to be the world repository of spine science, we need physical literature, like literature on paper that you can touch. And Joseph is not here, but he knows that his house will house the physical gems that we will find. I have a story about that. Like the current French president of the Spine Society is a hunter and discovered in an old farm in southeast of France the private collection of Georges Charpak. So Georges Charpak is a physics Nobel Prize. He invented the EOS, which is a full body image X-ray, and he has a private collection that would be burned unless Vincent Fier found this collection. And you have like tapes, you have letters with Jean Dubousset, you have like a ton of super interesting stuff that would be burned, and we are super lucky. And Joseph will host the physical component of the library, the private library of Georges Charpak, but Nassim in Corsica. So it will be super protected. Nobody will learn this collection. But also, with the technology of Nassim, it will be fully available online, and you could see like the videotape explaining how he did have his physical Nobel Prize. So it's priceless, totally priceless. Sorry, Nassim, sorry to interrupt.
Always very interesting, and it allows me to also make another point, which is that only a DAO can do something like this. Only a DAO can incentivize people to participate in, an effort like this. I mean, all these organizations like the Academy and libraries in general are supposed to be voluntary. They're supposed to encourage contributions. But again, if you know that down the line, at the end of the supply chain, the ones who are going to benefit and get all the value are, the publishers, Elsevier, Springer, etc. You wouldn't have, incentives and motivation to participate. And this is unfortunately the state of the academic. I think Virginie talked about this better than me. This is the state of the academic publishing industry. So at the end, you have these super for-profit, almost predatory publishers taking all the value. I think with the DAO, with the token, and also the collaborative nature of it, we have the perfect setup to, as you said, Vincent, onboard all the institutions, show them that crypto is really a mechanism design tool before anything else. So we would incentivize participation, encourage people. And just for this kind of data, I've read recently that big AI labs pay YouTubers or content creators to give them their unpublished videos and unpublished content. Now we have this treasure, this huge treasure of unpublished, non-digitized papers that are much more valuable, as you can guess, in terms of knowledge for AI, be it historical or technical or surgical for AI. So it has much more value than any private data that people have, and it is underutilized. So I think it's a really important source of value for the DAO to build this. And we have the perfect setup, the ideal setup with the academy to really do something important.
Super prestigious, super proud to work with you, Nassim. Thank you so much. Thank you so much.
Thank you very much, everyone. That's really
Sophia?
I do have a small anecdote about Vincent, and that illustrates how this is his dream. So when he did 1 year of research in my lab, more than 10 years ago, when I assigned him to write a manuscript, the introduction was already 10 pages long, always. And I'm like, Vincent, this is an introduction. He's like, yeah, but I had to go to the first description. I'm like,
I'm a teacher.
I'm like, and then I got a call from the librarian of NYU, not a small library. And basically the librarian asked me like, when is he leaving? When is he going back to France? I'm like, what's the issue? So the issue is that, of course, if you have a modern paper, you just go online and download it. If you have like something like from a few hundred years ago, there's already made to the library and they find it. And I'm like, Vincent, why do you need this paper written in Japanese? You don't read Japanese. It's like, it seems to be like the first one.
And there is a picture, there is a drawing.
It's like, I want to... Yeah, so that's really like this is part of the dream.
Yeah, absolutely.
Yeah.
Thank you. What do we do? Sorry, we move on Packer. Is that SpineTech? Yes, it's okay. Allez, let's go. So just to introduce Packer, so we are going back and forth our dream and our project. So Filter is the smart appointment system. Decide is the AI strategy assistant tool. And Tracker is how do I monitor in real time my patient from the maestro and the election.
Yeah, so we'll talk about Tracker. So first, I'll introduce the goals that we want to reach with that project. We talked about we talked about a lot about data, and the patient data is very important. As we said, it's very important to have qualified data, to have very standardized data. So the goal is to follow and evaluate patient. We want to know what's happening when the patient is not under the supervision of the medical staff. So we want to know when patient is not at home, before the surgery, after the surgery, at any time to be able to track and to monitor what is happening for the patient, in order to know the main thing that we want to know is if we are improving his health. So first is to follow and evaluate the patient, then see the patient performance, so the states and the health as it improve or not. Then we can also track, and we want to also track the surgeon performance, because it's part of the game. You know, you if you want to know if the patient is going to be better, then you have to know if the surgeon is doing good, also on his part during the surgery and after and around the surgery, what is it doing? This will lead to be able to improve the research, of course. We want to collect data, so we will talk about the means to collect data, but the main thing is to collect data, of course, and the goal also is to bring to have a bridge between apps, software, and devices, because at the moment it's a little bit there is a little bit of gaps between all those softwares and all those IoT. We'll talk about it. So what is really important to understand is that having a static picture is good to know how the patient is doing, but the best way to know how the patient is evolving is to have the live data. So that's what we want to get. And during the surgical pathway, we can classify the data and the timings to gather that data. So the first timing is the pre-operating data. So that's basically when the patient is starting consultation. So we can consider just the surgery and when the patient sees the surgeon, but we can also start with the first consultation, which might not be the surgeon, might be a general practitioner or stuff like that. So that if you can start collecting data very early in the pathway, then you get more precise in your prediction. If you want to have prediction, you can also be more precise on the patient health also.
Expectation.
Yeah. So for the consultations you have, we listed some of the tools that we can use to collect the data. So during the consultation, you can use tablet and clinical the symptoms, because the surgeon can have the patient can have pre-filled the symptoms before the consultation. So the surgeon is allowed to have all that data beforehand and not during the consultation. So it can shorten also the appointment better qualify the appointments. Then when you go further and you go to the step of the surgery, then during the operating room you can have a lot of data that can be gathered at that moment. So basically, smartphone stuff. You have a lot of data on our smartphone or on a connected device like the watch, Apple Watch, or stuff like that. You get walking, sleeping, walking is really important for the patient. The sleep also, because we know that bad sleep can interact with surgery, and all those different stuff like blood pressure, heart rate can be also good indicators. And something that is sometimes overlooked is the alimentation, because the feeding of the patient can play a role in the after the surgery. So what you eat before the surgery, how is your regime before the surgery can change how you recover after the surgery. So from the patient, there is after the surgery there is the hospitalization. We can collect the exact same data and compare them to before the surgery, and that's very important to have the baseline before the surgery, and then be able to track the data just after the hospitalization and when the patient will go home, because the main goal is to send the patient home the quicker the better. And we can still track a lot of data from the patient when he goes back to his home. And important stuff to notice is also that you can have connected fridge for the alimentation, for example. That's just an example of IoT that could be used to gather that kind of data. And also the social activity, and it's really linked to how you recover after the surgery. So if you can move, if you can walk, if you can run, maybe, if you're lucky enough, if you can drive, because driving is very, when you have the back pain, driving can be a big problem. So if you can go out and drive, then if you can collect that data, then you know that the patient is getting better and better. And so now we can go on the surgical prospect if you want. Yeah, so
I don't know if tracker is a good name, because for us maybe it's a good name, but not for a patient, because they are afraid by a spy, and is it a spy or is it just a tool for markers? Maybe we can change the name after, but for the work in SpineDAO, it's a good name, but not for the patient. And I think we will see after. But we have to be careful with the name and with the.
I think it is the same thing for filter, because filter could be a little bit problematic for the patients. But if we talk about smart rendezvous, it's better for the patients.
And sorry, because we like operate. It's a pathway for a surgical patient, but you want to be the operate. I think we need the engineer and the technician like you, because we like operate, we like see patients, and we can collect data, but we don't know as to coordinate and to collect and to study all this data. It's maybe the challenge, and maybe the challenge for Cortex and Khaled and Zimestad. We try with our team to collect the data at each step. We would like to collect the more data as such as possible, and we integrate all the practitioners and the paramedics in the game. When I am in the operating room, I tell to my anesthesiologist, yes, you have to put some data in my software. My assistant nurse, you have to put some data. Okay, when I go with my nurse coordinator, you have to put some data. Yes, but just on a paper. No. See, on a table, because I have a friend, Michael Cheney, who wants some tables and the same tables, because after that, Virginie is not happy. Yes, we have a lot of tools at each step, and we have now some tools in the operating room too, and I think it's really important. And we have a lot of data during the hospitalization, but we have no follow-up because it's not the same software between the clinic and our software. And I think we miss a lot of data, and we have to work on this part. And maybe we know that we are now in a new area, and so a lot of paper are based on 1 year follow-up or 2 years follow-up. For me, I think the most important is the month after the surgeries, because we would like to be comfortable to have no pain, blah 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 blah. And you can see it's one of the tools used by the physiotherapist, and you can in 5 minutes have a lot of parameters with some tests with the physiotherapist. Yes, what we want.
Just to finish, so the goal is to have a dashboard that is able to give all that data and to aggregate all that data for the surgeon, also for the patient, of course, because the patient wants to know. You know, when you have a smartwatch or stuff like that, you tend to look at it more and to compare what you were before and where you are now. So that's very important also for the patient. But the main goal is to have the practitioner to know exactly what is happening to the patient. If a patient is going well for, let's say, 1 or 2 months, and then the health goes back to bad, then it's very important for the surgeon to know that. And if it needs to reoperate it or something like that, it's something that it can be done with a dashboard. And to finish, also, we need to keep in mind that all of that is not being a spy for the human, but it's just try and improve the health of the patients. So, as you said, filter, tracker, or filter are not the best names, but for the patient, we have to find names that they can relate to, and it's very important for them to understand that the data is not to track them, is to help them improve their health. Yes, thank you for the time.
Maybe we can think also about for the patient to be involved in this journey, to have maybe a heal to earn program. Like you're a 70 years old patient, you pass because you have a stenosis, so nerve that controls the legs are impressed in the degenerative lumbar area. So your working perimeter progressively goes from 5 kilometers to 500 meters. So the surgeon opens the canal, decompresses the nerve, and then after the surgery, we can put intelligence and data set to say, well, all the patients that the 70-year-old patients that have this recalibrage, this decompression of the nerve, has this, in average, pass of recovery in their working perimeter. So they pass from 500 meters, and after surgery, in the first month, they can do 1 kilometer, and then 2 kilometers, and then 3 kilometers. And if you achieve these goals with your connected object, you can earn some spine token. So if you achieve milestone, you earn token. It's a concept of here to earn, and also not putting patients in competition, but to say like, well, in our data set, we have this data, and it could stick to your program. And we could also add a tailor-made program with physiotherapists, coaching, mental health enhancement, in order to have a better adherence of the post-operative program, because that's the main problem with post-operative clients. Thank you so much, guys. So we finish the session with Wojciech, or we lunch, and then we do. Let's do Wojciech, because I'm so proud to have Wojciech from Data Lake in the house. I mean, he's the big name of the day, and we're super proud to partner with Data Lake. Not only because Data Lake is a big name in DeSci and in the DeSci game, and they have their token running, and we can see them going up and down. Up and down, and yes, you're super important in the DeSci ecosystem, but also because they are super nice guy, and we talk with Piotr, and they are super serious. So let's talk about consent and data storage. Thank you so much.
Thank you, Mr. Right. Hi, everyone. So apparently I'm the last one standing between you and lunch. So I'll try to do it really briefly and try to deliver some value to you. My plan for the presentation is to take about 20 minutes talking about our framework for actually creating valuable data sets. I took the liberty to change the presentation topic a little bit, Vincent. I hope you're not angry with me. But after that, for 10 minutes, we are going to talk about a specific case of patient recruitment and managing the consents and ensuring the whole compliance framework. And then we are going to end with a brief note about our collaboration and what we hope to achieve together between Data Lake and SpineDAO. All right, so let's get to it. So that's the plan for the presentation. Really short intro, dataset creation framework based on our experience, some live demo, and SpineDAO X Data Lake collab announcement. So what we do is we were born about 4 years ago as a decentralized science organization before decentralized science was decentralized science. And we are born out of kind of a naive idea of creating the first in the world data donation framework. So we wanted the patients to be able to donate their data for some future research. Of course, this hypothesis was validated many times down the road. It turned out that as an organization, we actually also need to make money and we need to figure out a way how to be profitable, which we did. And right now what we do is we do contract research for major organizations, for pharmaceutical companies like Sanofi, Novartis, and a bunch of others. We work on the patient registries, so we create, curate, operate, and do research based on structured and periodically updated databases. We do it in oncology, for example. We did the research on 600 patients, which was a patient pathway research in breast cancer. We recruited over 150 patients to over 25 clinical trials, adult and pediatric. We captured half of the population of patients with a rare disease in a patient registry in Poland. In the process of exploring the data donation scheme, we gathered more than 60,000 patients to become data donors on our platform. And recently we launched the first scientific study that rewards patients in crypto for contributing their data for an AI algorithm development. So the reason why I mentioned this is actually today I want to share with you some high-level insight and some learnings that we acquired during that process that came with hundreds and hundreds of costly mistakes that we did. So I hope that this will also be useful at some point for you when you think about creating data sets that are actually useful, valuable, compliant, legal, and so on and so on. So in the next slides, we are going to break down all the steps necessary to ensure success of your data collection. We have based our process on the guidelines of the Agency for Healthcare Research and Quality, which is an American guideline, as well as the parent and request guidelines, which are European guidelines. So let's go. We are going to have a couple of steps, but it all starts with the first step. So why actually we are doing this? Why do we need this data set? What do we need to accomplish? Right? So what question do I hope to answer? For whom it will be important, right? Am I creating a data set for policymakers, for patients, for innovators, for developers, for clinicians, for my community, for the token holders? We have to be cognizant to whom it's actually useful or to whom it's actually going to be useful. Is my research question answered best via quantitative or qualitative methods? Because in medicine, at least myself in my medical school, I heard only about quantitative methods, which were like a pinnacle of the scientific evidence. But it also happens that there is a bunch of data and a bunch of valuable insights we can learn via qualitative methods. So unstructured data capture, patient interviews, patient pathway mapping, process mapping, and so on and so on. It all depends on the question we are trying to answer. So what epistemological approach will be best? Are we going to take the interpretivist approach or not? Is our research actually needed? Have we done our homework? What does the literature say about it, right? So we all have to take this into consideration, and this is our North Star as we go forward. The second step, which is really important, which I tended to neglect, but I especially in medicine, where most of the barriers are not technological in nature, right? They are organizational, they are cultural, they are process barriers, they are not strictly technological or regulatory. So it's very, very important to identify stakeholders because there are people who will wish you well, and there are people, if you don't include them, they will not wish you well, right? So it's very important to know in advance whom they are, who is important for the study success. In the contrary, who may sabotage your research if they are left out. If working with organization, which is really important, on how many levels of the organization you actually need to lobby. Because securing the buy-in from the CEO or the president of the board, many times it's not enough. Because the people doing the actual work are the people on the ground. Have you taken the time to actually talk to them and to make sure that they are on board with your research efforts? Because in many hospitals, in many organizations, the CEO, it actually doesn't have that much power, it turns out, right? So whom do I need to consult before we start? What's important to my stakeholders? Is it money? Is it prestige? Is it recognition? Is it attention? And this tends to be very diverse, even between doctors, clinicians, and patients. Do I need to include patient perspective? Do I need to include clinician's perspective? And how much time do I actually have to carry out all those necessary stakeholder consultations? Step 3. So based on the study purpose, so we always remember our North Star, we think about the scope and the patient population. So based on our goal, which patient population will help to achieve my goal? Where do I find them? How do I talk to them? What kind of language do we use? What kind of graphics do we use? Do I want to control many variables by setting very narrow inclusion and exclusion criteria? Or do I actually want to, by design, embrace complexity and have people with diverse conditions to see how this plays out more in the real world rather than a controlled setting, right? So here's where we also set our inclusion and exclusion criteria and we think about our study participants. 4 important steps, which I also tended to neglect because I'm an optimist by nature. So feasibility, can I actually do it? Given the budget, given the time, given the team I have, the expertise, or do I have to adjust my goal and adjust my strategy to actually serve my research? What kind of data do I need to be able to make an informed decision about this? Do I actually need to run some kind of pilot? A study? Do I need more expert consultation or literature review? To whom do I need to speak, right? So now we are talking about the feasibility, because if we don't do it, it's really painful further down the road. Secure funding. I'm not an expert. Talk to the folks at FioXYZ. Paul, give us money. Exactly. Step 6, recruitment target and strategy. So from our experience, the recruitment strategy for patients, it's actually what makes or breaks the research, right? So here we need to think first, is the patient consent needed? Are we capturing patient personal data or do we want to capture anonymous data? If personal data, then under GDPR in Europe, we actually need patient consent. Do I want to contact my patients in the future? If so, I also need to collect separate consents for contacting the patients, which may be useful. How do I reach my patients? Where are they? Are they in the internet? Are they in the clinics? Are they on the street? Are they on Instagram? We have to think, where do we actually find those patients? Do I need to reach them directly or do I need intermediaries, right? Because if I need intermediaries, then this adds more cost and complexity usually to my research, but I can access my patients perhaps more precisely. Do I target patients or caregivers? Does my population also comprise of people who are handicapped or pediatric population? What do they have in common? Which media channels do they use? What's the language I need to use to reach them effectively? Where are they treated? Are there any professional associations specialized in that condition? Are there patients' organization? And the last point, which is super important, what's the cost of patient acquisition via those channels? Because even though, if we look at the physician ethical code of conduct, it's actually a great area. So physicians formally cannot be paid for referring patients. However, we can be paid for the work that we do. And recruiting patients to a scientific study inevitably involves some work. So most of the time, we can actually pay physicians for the work that they do, which is connected to educating the patients about the research. which ends in recruiting the patient to our study. And what we saw across our studies, this is actually a really powerful stimulus because physicians are busy. So kind of playing around with the incentives actually makes a difference. So we also have to be cognizant, do we need to pay, to whom we need to pay, how much money is enough, whether it's a market value also, and whether we are still within the ethical framework of paying for work, not for the recruitment of patient. Later, observation period, based on my budget and the study purpose. Do I want to conduct a cross-sectional study, or do I come to update my database periodically in the future? And do I have a set period of time for observation, or is it indefinitely? Are you still with me, folks?
Yes.
Good. You should. We are almost done. Step 8, defined the endpoints. So I look at my study goal, and I ask myself these questions. What endpoints are my area of interest? Can I be absolutely sure that they happened? For example, many times we don't know whether the patient was lost to follow-up or they died, right? What outcome measures are appropriate? What's the risk of bias in my measurements? How can I capture data about my endpoints, direct from the patient, from the medical records, from publicly available statistical data, from the caregivers, from the clinicians, right? And all those data sources have some certain level of objectivity. For example, if we take the data from the hospital records, we usually think it's really highly objective. On the contrary, if we rely on patients' subjective reports, it may be of, let's say, lesser quality, right? Do I need to access patients' medical records or other kinds of data, and how objective is my data? What are the confounding factors? Now there's some data work that we need to do. So we think about our data elements. More data, it's not necessarily better. And that's the mistake we've also done many times. More data comes with more work, more cost, more burden of structuring the data. So we have to actually go back and be really, really disciplined about thinking, what scope of data do I need? Because collecting broad scope of data from everyone for the future about everything, it's actually not that useful, and it's usually not economically justifiable. So how much data is enough for my study? Number of cases and depth of data. Do I plan to collect more data than necessary? If so, why? And what's the 80-20 rule here? Which data elements are obligatory and which are not? So this is kind of the escape button in case you really want this data element, but you can't really justify why is it necessary for your objective of the study. You can always include it as an optional data element. What's the data collection burden? Is the data entry done by the patients? So do they actually do the physical work, by the clinicians, or by my team? In our case, for example, most of our research is done by our team because we collect both the patient consent and the power of attorney. And in most of our studies, we access the data from the healthcare entities based on the patient power of attorney, because in the European Union, but also as far as I know, in the US, medical entities are actually legally obliged to release the medical documentation to the patient or to the power of attorney holder, which means that clinicians and patients don't have to do much, just give the consent or collect the consent, but we actually have hundreds of pages of unstructured PDFs, right? So who does the work? It's a really important question. And what kind of data quality can I expect? Taking into consideration who does the work and whether they are actually adequately trained and adequately compensated. What we do next is we map data sources. So to the presentation of my previous colleagues, we can draw data from multiple sources. So we have to answer the question, who has the data I need? Is it the patient? Is it the doctors? Is it the medical entities? Is it in the wearable sensor data? Where is it? How likely are they to share it with me? Because, for example, what we struggled with in our country is the public or cultural perception of the risks associated with sharing the data, right? So the reason why we deviated away from using the notion data donation in public is because it was perceived risky by our stakeholders, right? Data donation. Donation is like organ donation. Are patients actually alive or not? Is it risky? this has something to do with GDPR. So the language actually matters, right? And this was perceived too risky. Our stakeholders were not willing to work with us. What kind of incentives will be needed? It doesn't have to be money all the time. So for example, in case of our rare disease patient registry, it was more about attention and recognition on the side of the patients. They were actually happy that there is someone who finally thinks about a structured data collection exercise about their condition, which didn't take place before, right? So it's once again going back to the incentives and the stakeholder mapping, which is so important. And what's the data structuring burden connected to every source? For example, health data that comes from medical facilities comes in different formats. They can send it to you on paper, in unstructured PDFs, in structured PDFs, in JSON files, in HL7 FHIR files, right? And it all comes with a different data structuring burdens. Then one of the last steps is we think about data capture and storage technology, right? So once we know where we are getting our data from and what are the data elements, then we have to answer those questions. Is my technology capturing structured or unstructured data? If unstructured, what's my strategy for structuring the data? Is my study qualitative, quantitative, or mixed methods? Because there are different tools for capturing these types of data. What are the regulatory requirements? What are the security measures required? What are the organizational processes I need to engineer? What are the access levels to the stored data? And have I taken into account the data privacy aspect, for example, data protection impact assessment studies, the presence of data protection officers, and so on and so on. Then we move to the data quality management, which also depends on the type of data you're capturing. But this is the mistake we did in our first trial. We didn't think about it at all. And then we ended up correcting our database 7 times for every single entry on the database of 600 patients, which was a nightmare. So we have to plan it from the get-go and answer the following questions. How will I ensure adequate data quality? How will I ensure consistency in my data quality? How do I plan to train my team? And generally, in my experience, having in-house team members who do it every day as a part of their job description is far superior to outsourcing this or relying on medical students, which we also did. Will I structure my data in-house or do I plan to outsource this? And who will be responsible for data quality in my organization? There has to be a person with a whip who comes to your office every day and who actually makes sure that the data entry is done according to your data quality or management plan.
But you used to have a femur. A femur is way more efficient than probably. That's like
a human femur.
Yeah, no specimen.
We need to get that. We need to get one.
Yeah.
And last but not least, ethics, data ownership, and privacy. So, is the IRB approval and bioethical committee approval required for my study? We recently went through this, and our read of the law and the literature is that, for example, in our patient registry, it's not legally required to capture the data, but we wouldn't be able to publish it if we don't have the bioethical committee review, right? So it's not required, it's not illegal to do it without the bioethical committee approval, but it's unethical and your research wouldn't be published. So most of the times it's advisable to do it. Are the patients adequately informed? What's the risk-benefit ratio for patients? How is my study useful to patients? About the ownership, who is the owner, the custodian of patients' data? The term ownership under GDPR, it's actually quite tricky. It's not very precise because we are not talking really about the ownership of data because ultimately the patient is the owner of the data. We only may be the custodian, which comes with more obligations actually than let's say benefits, in my opinion. Whom do I share the data with? What are the rules? So all the data sharing agreements between me and the third parties. And about the privacy, how do I plan to maintain patients' privacy? Which is obviously a broad question, but I don't want to go very deep into that given the time, because I have 30 seconds to finish. What is my team and advisors? Do I have the competences that I require in my team? Who's missing? Who do I need? Do I plan to have part-time or full-time involvement of my team members, in-house, outsource? Who has the knowledge I need? Generally, in-house better, quality, but also comes with an additional cost of management people and so on and so on. more thoroughly about the governance and oversight. And this is one thing I think it's very important, but it's also very important not to overdo it. So first we need to ask a question, do I actually plan to have a governance body? Why do I want to have a governance body? Who will the governance body comprise of? How much time, money, effort will I need to gather and manage this? For example, in our patient registry, we have a governance body that comprises of 12 highly reputable physicians. Half of them are national consultants in their specialties. So managing them comes with a lot of overhead and organizational burden, because you can imagine what it takes to synchronize all their calendars. So it's great from the reputational standpoint, but once again, it's a cost and also it's a risk. If something goes bad, because they don't like each other or whatever internal politics they have, they can actually sabotage my study. Because you manage the egos. You have to manage the egos. And if you have 6 national consultants, the 6 or, multiple data of egos, it's actually really important in that. Is it going to be in advisory or decision-making capacity? Do we want them only to talk and give advice, or do we actually want to delegate some decision-making power, for example, with whom we share our data with? Do I have the governance documents in place? Are they easily accessible by our stakeholders? Can the patient actually go and see what's the governance plan of my database registry or my study, right? Okay, and last, we don't live forever. Although we plan to be the Alexandria library for the spinal archives of the world, it's also good to think from the very beginning what will happen to the data when we don't exist no more. Will another organization be able to take custody of the data that we collected? Does this influence my consent and governance structure? Do we need to collect the consents for the second organization from the very beginning? And is that organization actually receptive to taking that obligation and risk of being the personal data controller of the patients, right? Amazing. I almost made it at time, 8 minutes. So now let's see everything in action with some web-free flavor. And I'm going to show you the project that we launched recently using our technology for managing the consents and managing the patient recruitment flow, which is a project for developing an AI algorithm for detecting skin malignancies based on the images that patients directly upload on our platform. Can I access Chrome here? Yes, to go. So that's the platform that we recently launched, where researchers can publish their studies, and patients are rewarded in cryptocurrency for participation in those studies. That's a short study description, and the patient agrees to the terms and conditions and the privacy policy of the platform, and they are directly taken to our consent management and consent capture software. It's fully customizable. It can be used on mobile devices, on tablets, on laptops, on telephones. And later, I will also show you how we can configure the collection of different types of signatures. So here's where I type my email address. All right, fantastic. Wait, displays in Polish. So we'll type your data. Oh, there you go. Yes. And your telephone number. In presence shame. No, almost is out. Then relax and is the role this my listen. Amazing. Without this is if you're signing for your child. That would be your MetaMask address. Whatever. Let's see if the validation will work.
This is for the patient.
Pardon?
This is for the patient.
This is for the patient, exactly. Here we have a bunch of consents that we are toggling. This particular research doesn't require a handwritten signature. What we can also do in the software is set the requirement of a handwritten signature, which has the features of a biometric signature, depending on the type of device that we use for the signature capture. Generally, different devices collect different signature elements. So to have a fully ISO compliant biometric signature, you need to use a tablet with a smart map to also capture the pressure of the signature. Most of the times you actually don't need it. And after clicking the next button, your consents were already given. And now we can log in with your email and your telephone number to our application, which is and you can type app.data lake.
Data lake.
Yes, .data lakes. Yeah, exactly. Just, yeah. Yep, enter.
Just put.
Yes. And you can log in by Google too. If it's a Gmail account. Come.
This was this one there.
Mm-hmm. Hey. I will have to click on send the code. I don't know why it detects a Polish person behind the screen.
It's working.
It's wait a second. Yeah, now it's clicking to Yep. And verifies whether the button exactly. There you go. Let's finally change this barbaric language to another barbaric language. And you can go to the tab My Data, and here you see the consents that you gave, right? So you gave the free consents, and you can withdraw your consent with one click of a button. And what you see here is you also see the traces of the consent on the blockchain. So let's click on the operation hash.
So now the consent is inside the blockchain.
Exactly. And let me show you how it actually, what's the anatomy of the consent on the blockchain and what we capture.
On what blockchain? ERC.
This is on our rollup. It's an ERC20, but it can be deployed on any kind of ERC20 network. For example, on Ethereum, but then it will be expensive. So here you see that we use the method in our smart contract of signing the consents. The consent is already processed on the rollup. It will be sent to the parent chain for the cost reduction. And if we go to the logs of the consent, this is the data that we capture about the consent. So first is the user signature, which comprises of the patient's personal data with a cryptographic salt, which is then input into a hashing function, which means that we cannot deduct the personal data of patient from the hash from the blockchain, because otherwise we would have also data compliance issues.
Everything is encrypted.
Everything is encrypted. Only the patient can see the salt. So if they take their name and surname and they add a cryptographic salt, they can derive the hash from that and query the blockchain directly to search for their own consents, right? So first we have a parameter that tells us who actually consented to the research, which is the user signature. Then we have the second parameter, which is the consent hash. We take everything that we put in a consent and we create a cryptographic hash from the content of the consent. So even if we change a single comma or a single character in the consent, that will result in a different hash. So we can prove beyond any doubt that this is what the patient consented, right? Then we have the timestamp, which is important. So when the consent was given, in case of minors or handicapped people, we can also collect a second signature of the legal custodian or the legal guardian of the patient. We can add a note, which sometimes is useful if we want to, for example, type something about how we collected the consent. And last but not least, it also contains a signature of the account that was used for signing the consent. And thanks to that, we can track who collected this consent for us. So if we worked with a bunch of physicians, with a bunch of doctors to recruit our patients, we know who actually contributed to patient recruitment efforts, right? So all those consent parameters live forever on the blockchain, and you can always prove undeniably that this patient consented to this consent in a given way at a given time, right? And of course, on the administrator side, you have the panel for management of all these consents. And should you wish to do it, you can also have a nice image of your consent, which is very handy if we want to present this consent to a medical entity. In that PDF file, you can also directly access the blockchain link. And you have the signature verification document with all the important signature parameters, such as the operation hash. And with the operation hash, you can query the blockchain directly and discover all the other consent parameters. All right. Where's my presentation?
Just on the super on the platform, there is a part where it's token. What does it mean?
All right. So in all our research projects that we publish on our platform, patients are rewarded in our token and possibly with another token if the researcher wants to set this up.
And this is legal to give some token to the patients in Europe, in everything?
Yes. So we can imagine using this. Well, I will answer this more precisely in a second because there's also some intricacies.
Go on, Bridget.
Okay. So generally, you can reward the patient, but not to an extent in which this can messes with the informed aspect of the consent, right? So, for example, I can give you a voucher for a book or for a medical consultation, right, as a sign of gratitude that you enrolled in my research. But if I pay you $1,000, that can actually make your consent not informed. But best practice, this is evaluated by the bioethical committees and should be discussed.
Yeah, that's the same like a classic clinical research. So you can give the patient some incentive, but you have to be like proper because if not,
it's too much.
Same with the doctors, by the way. Yeah.
So we can think about applying this system to, for example, AI agent, Lamina, Filter project. Like people are passing through this system to have a spine incentive to put their data. The content of the data, it's I didn't see that on it's not on the note.
It's done in a separate system. So this is only done for managing the recruitment. So using this system, I manage my consents and I manage my recruitment network. So I want to know who recruited how many patients and when.
Exactly.
Because I need to pay them.
Yeah, for sure.
But the data capture system is a separate one.
And the data is not on the blockchain.
Data is not on the blockchain.
In this case, who's the custodian?
In this case, a third-party researcher. So not us as a company, but a company called Mathmetrics that distributes this AI algorithm, and they take care of the data validation on the backend, and they are the legal data controller of the patients.
And they are liable.
And they are liable. We are the processor in that case, so we are a technology provider.
And if you want to connect with our software, our daily software, is it possible if we have the agreement with the patients? Because, for example, Steven is from Follow, is our software for the daily practice.
Mm-hmm.
And if we imagine that the patients put his data on this part, and then we can push the data to Follow, but we have have to have the agreements.
I will answer your question the way my developers answer my question when I ask them if something is possible. So they say always yes. It's just a matter of time and cost.
Okay. Steven, you confirm?
Maybe it will not be that much, but of course we would need to look into this.
Well, the issue, Steven.
Yeah, so in the platform, they already have a cost control. And because I think we have two discussions. We have a discussion on data, and the discussion of cost control.
Conform for the operation. No, this is the conform for the.
No, because in Follow,
for the data, it's conform for the data, or it's conform for the.
They're both, because at each consultation you have to sign the consent form.
Yes.
But it's just
if you take from the it's just if you give your data from the tablet, but if you enter directly some data on the software, you don't have to sign something. The data is the consent form is just signed if the patient enter by himself on the tablets.
Exactly.
But not for each data.
Like when he's physically in the office, the first thing that he do on the tablet to sign the consent form, you say, okay, my data can use for scientific purpose.
Yeah.
So basically, they're talking about a platform that is used for both as a
EMR. Right. Prescription document,
and research.
But this is the next level, because the consent it's immutable inside the blockchain, and so that's correct. Yeah, that's the next level. Yeah, and
you can withdraw your answers.
And you can withdraw your consent anytime. So and it also has the history of all your consents operation. So if I click withdraw consent and I confirm, now I can see that the status of my consent will change. Wait a second. Oh, I think I got logged out. So I will not show this to you. But there would be a second operation on the blockchain, which is a consent withdrawal, and the status of the consent would be different.
Yeah, sure. If I have a rare disease that is not visible, and I consent to participate in a study, this rare disease, does it mean that I stay to the world and I have this disease, or do I have a way to protect myself from that?
Let me make sure I understand your question properly. So you have a rare disease.
Yeah, let's say I have a rare.
Yes.
I want to participate in national study on rare.
Yes.
My consent is on blockchain. So,
but without any personal data. So what lives on the blockchain is only the hashes, the consent hash, your personal data with a cryptographic salt hash. So if you don't know your personal data and the hash, you have to know both. You are not able to decipher the user hash that lives on the blockchain. So even if somebody knows your name and surname, they only have a part of the ingredient that is necessary to decipher the hash on the blockchain.
And is the hash specific to both myself and the study? Or do I have a unique hash called many studies, for example?
No, you don't. That's a very good question. Because if you did, then theoretically, the doctors who are capturing your consents could link, this consent hash to multiple studies. So they could know that, for example, you consented to this protocol, but also to XYZ protocol. So deliberately, we designed it in a way that it's generated. New cryptographic salt is generated for every consent that you give. That's a great question.
And will we have also a way to have on the blockchain that the data is still the same data that the patient put at the beginning, or
that's why we have
if the patient change something, or if the doctor change the data,
that we have the node parameter.
But it's just for the form, for the consent form, not for the data.
They didn't talk about data.
Yeah,
this is only.
But what we could do, because I understand your point, what we could do is to take the data, whatever data that is,
and certify
and hash it.
Okay.
And in the node also store the hash. So going back, we are able to prove that this data was actually input during the consent capture.
And if the data is changed by the doctor or by the patient, we can have another hash. Okay.
Yes, and update. So for example, what we also do is we have the full versioning of the consent forms. Because what we discovered is also we change the consents all the time. We add this, we remove that, and so on and so on. So in our system, we also have the full history and the logbook of all the changes in the consent forms.
Okay.
Some questions about the future.
I'm so happy about all those questions. I thought it's going to be legal topic.
I'm pretty sure you thought about storing the proper data.
Yeah.
Chain, and it's too heavy, I bet.
There are two problems with that. So the first problem, it's actually with patients' sensitive data, which is a special category of personal data under GDPR. It's super tricky legally, probably illegal.
Yeah.
Because you have to be able to prove the geographical storage of data, which has to be within the EU. And some countries like Germany, for instance, require that data has to be stored on German soil. And you're not able to do it on the blockchain. And second, it's not even about the size, but also about immutability and the right to be forgotten under GDPR. So you need to be able to delete the data if somebody asks you for it. On the blockchain, you can't.
Yeah.
And of course, the third aspect is the storage aspect, which tends to be lesser of a problem because there are IPFS networks and so on.
Yeah, but the retrieval is not working properly. And
that's true. That's true. It's just not a proper tool, in my opinion, for medical data storage.
But also for utility, there is no direct benefit to have raw data on blockchain.
Not at all. I think the logbook of the relevant operations connected to data, it's important to have, right?
Sure.
But the data,
the salt, where does it get created? In the blockchain, in the EVM.
Again?
Where does the salt get created?
In our system. So it's a randomly generated 4 words. Wait a second. It cannot be created on the blockchain because it will be public.
Mm-hmm.
And it has to be known only to the patient.
There. Wow.
So wait, in terms
That's right. Like,
Yes.
you can't use like AWS, for instance, right?
We can. AWS is perfectly fine.
Okay.
Absolutely, yes. It just has to
As
be,
long as it is in Germany for German.
as long as it's configured according to the data protection standards of your country. Yes.
Okay. Okay.
But there's no problem in with cloud storage.
No. I was asking about that in relation to what you said about like German,
Yes.
like data storage.
Yes. Yes.
Like if you remove the consents and like how that affect the data and how fast does that affect the data?
Right now, we don't have an automation deployed. So what we have is we get a notification that somebody removed or withdrew the consent. And then we are legally obliged, if we are the data controller, we are legally obliged to stop processing the patient's data. And there can be two cases here, because you may have anonymized patient's data prior to the consent withdrawal. In such case, you don't need to do anything with that data. It's already anonymous, doesn't belong to the patient anymore. You don't have to do anything. But you need to remove the patient records from your database, right? Name, surname, telephone, yada. But we don't have an automation for that. We could possibly, but in all honesty, consent withdrawals are quite rare. So for 60,000 consents that we collected, we had like 8 withdrawals. In the rare disease, 0. So far it hasn't been so burdensome that we would have to make this.
One guides. Super. We will change.
Cool. Most important slide.
Yeah.
I know. Yeah. What do we do now? What then we have to move?
And now we go for lunch in 30 seconds. That's the good news. And we are going to work together. We are very excited about this perspective. And here's what we plan to do together. We plan to use data lake consent stack to capture, store, and manage patient consents in line with GDPR and industry best practice. We are planning to put in place all the required GDPR compliance and data privacy processes within SpineDAO, and configure a secure and compliant environment for data storage, access, and sharing. Thank you, everybody.
You talk about 100 or 1,000 of patients, but
yes,
in the community, we talk about 10,000, maybe 100,000 patients. It's not a problem for you to have a lot of
consent data is not very heavy.
Okay.
And I think it's like with one of the, I don't remember if it was step 1, 2, 3, 4, 5, 6, 7.
For sure thing.
Starting like, we started like with a huge enthusiasm, saying, oh, we're going to collect like 10,000 patients and like 6,000. Like, we have to go back, say like, what do we want to do? Do we actually need 10,000 or can we make with 500?
But this is precisely how we started. We started with an idea for medical data donation platform. So let's collect consents prospectively from everybody, because one day in the future we might need their data. But it was just ineffective.
Yeah. Another question.
I'm a barber in the US. Can I use you in the US or you just European?
Absolutely, you can use us in the US. The reason I focused on European regulations is that we are very good in regulations.
Wow.
And data protection regulations tends to be more strict in Europe. But having said that, should be absolutely fine in the US because as far as I know, under HIPAA, the regulation is quite similar. Sometimes just less strict, but I'm no expert in HIPAA and we haven't used it in America yet.
Right. But do you need like to have some form of like certification, say like, because right now like you are recognized as being like a complex. Do you need like, I don't know, somewhere like to...
For sure, we would have to work with an American law firm to figure out whether it's HIPAA compliant. So I wouldn't be able to give you a stamp of approval that it's HIPAA compliant right now.
Not yet.
Not yet.
Yeah, to be that really more sure.
Time and money.
Hi, everybody. Exactly.
Good. That was step number 2. Yes, thank you so much. Thank you.
So, my name is Michael Chali. I'm an orthopedic surgeon specialized in shoulder surgery. And as every good doctor story, it starts with a patient, always. So it starts with this woman. She came to my consultation like a few months ago. and I have operated on her of a shoulder arthroplasty. And she told me, I'm very happy with the surgery, but I'm very unhappy with you because you scared me out. And I said, why? She said, because you told me that after a reverse shoulder arthroplasty, which is a kind of shoulder arthroplasty, I may not put my hand in the back anymore. And I can do it. So you scared me out for nothing. And she was right. So I scared her out because I thought it was my goal to inform her of any potential complication, but she didn't have these complications. She was happy with the outcome, but not with the information.
She gave her agreement for the future, yeah, for sure.
Yes. And the problem is that the average patient does not exist. So if you take this bell curve that everybody knows, because we learned that, you know what is the probability to be exactly on the average? Zero. Yes, by design. So nobody is average. You cannot say an average outcome to a patient before a surgery and expect to be right. You will be wrong, whatever. The second problem with statistics as we know them is that linear relationships do not exist in real life. So there is no straight line that you can rely on your patients and trace between your patients. So for example, we all know that smoking kills, but we also know that smoking kills many more adults who are 70-year-old, who have diabetes and have done strokes, than they kill young people of 16-year-old. So smoking kills, it depends, okay? So linear relationships do not exist in real life, but still we rely on this kind of equations for most of our predictions in clinical situations. This is the concept of precision medicine. This is where precision medicine comes in. So the definition of precision medicine is quite broad, but usually it's saying that we personalize the medicine, the treatment, and the information to a specific patient. So it's tailor-made medicine. It's actually nothing new, precision medicine, because big tech use precision for many years. So it's been more than 10 years, 15 years that we are so used to algorithm. Like you would never expect to open YouTube and have like a bland page with nothing that matters to you. It's always personalized to you. It's the same thing for Netflix, for Amazon, for whatever. So we are already used to have personalized content. But us, as surgeons, we are not used to provide specific and customized information. Of course, we want to customize the treatment, but the information for the moment is just like generic information. And this is nothing new in other industries as well, because precision farming, for example, has been existing for many years. And still, in medicine, we are very, very late, but not that late. The FDA approved more than 1,000 AI-enabled medical devices. So that's quite new, but it's coming up. 1,000. So just a few examples. Of course, Cortex will be presenting the very great medical device, but just a few that were approved that I found. iBox predict kidney transplant failures, so you can say if a patient needs a transplant failure. Prognosis identify the patients at risk of sepsis. Acumen for perioperative hypertension, and iRhythm for detecting atrial fibrillation. All of them have been approved by the FDA. These are algorithms, but these are also medical devices. These are like drugs, like numeric drugs. So how to democratize and increase machine learning algorithm development? How can we give that to physicians so they can create their own algorithm? This is where Sciencer, our company, comes in. So it's the first studio that allows physicians and industrials to design AI-enabled software as a medical device. So SAMD is a software as a medical device. So what does it take? It takes medical expertise. This is you. It takes quality data. That's very important to have very good data.
This is not you.
And you put all of that into Sciencer, and hopefully you may have an FDA-ready medical device. Okay, so let's have an example. Let's take the example of filter that we have just been presenting this morning. So the goal of filter, maybe the name has to be changed. Maybe we should call it fast track, because the goal is to offer a quicker consultation to patients who need it. So how we took a database from you, Guillaume, and we looked in the database all the patients that have been operating following the first year after the consultation. Okay, this is the basis, and this is the metric, the outcome that we want to optimize. We want to have as many patients who will be operated in the first year as possible with this algorithm. The first thing is to know the data. It's like very basic thing, like cleaning the data, doing statistical descriptive analysis. So how many patients were operated in the first year? 16% actually. And who are these patients? So let's do like just a quick comparison. Let's compare the patients who have been operated within the first year and the one who haven't, based on their gender, their BMI, smoking habits, pain, etc. And the software will do like statistical analysis with the p-values, with the charts, everything like that automatically. So we can have like a broad idea of who these patients are. We can refine the way the data is used because, for example, for smoking, it's quite hard to analyze the data as it is of today because we have 5 classes and we don't have the non-smokers. So we can customize that and we can reorder the variables. So I want only 4 classes with one being 0 cigarette. So I can just reorder my data like this dynamically and have a new clean data like this to do my statistical analysis. So that's really the basis of doing machine learning. You need to do like basic descriptive statistics. Then we will do a quick prototype. So what does it mean? Okay, we are still in Sciencer. We are doing a new project called Filter, and we want to optimize the variable that I just told you about, which is operated within the first year. Okay, I will first create a data set and I will put all the variables that I want to include into my model. So I create my data set like this. One characteristic of this data set is that we have a big imbalance. So we want to augment the data. We want to create like fake patients, simulate patients who were operated. So we don't have a bias towards not operating the patients. We create the data set and then we will start training. So I go to experiments, new experiment. I choose a data set and I choose a metric I want to optimize. So sensitivity is very important in this case. I don't want to miss patients that needs a surgery, okay? I may see too many patients that don't need a surgery, but I don't want to miss the one who needs surgery. So I will optimize the sensitivity of my algorithm. I will do a quick training, like just 5 minutes, and I will click on Start Trainings. So now the software will automatically create this algorithm, optimize them in the backend, and choose for me like the best options, okay? So we have logistic regression. This is like standard. Neural networks, extra trees, exegesis, etc. And then I have this leaderboard, this table, and I can order my algorithm based on their sensitivity. So I can pick the one which has the better metrics. But metric is not all, okay? This algorithm, they can be very sensitive, but they can be also very dumb. So I want to understand what's behind this algorithm. And I can compare this algorithm on other things than the metrics. I can compare them, for example, on their explainability. So if I have 2 algorithms that have exactly the same performance, the same metric, is there one of the 2 that has a better explainability? So this is why I have this view. And you see these 2 algorithms, they are basically the same for the sensitivity. But in this one, the reason for consultation is the main parameter. And in this one, it's the pain level. So I can choose on my clinical take which algorithm is the best for me in my situation. Okay, so let's take the second one and let's analyze further. Oh, I can also see the cost and the ecological cost of my algorithm. I can compare them on that.
Thank you, Michael.
Yes, success.
Cool.
So let's take this algorithm. I will have like all the metrics. I can see exactly how my algorithm behaves. What are these performances metrics? All of this like very standard in machine learning, in predictive machine learning. But it's not everything. As I told you, we need to see if this algorithm are explainable. We need to go further. We need to open the black box. And I know, Guillaume, that you spent a lot of time digging into the software because you used Sciencer and you dug a lot into it, into the data. We had few calls for that. So opening the black box is, for example, seeing who are the patients where the algorithm performed less. So I want to see these patients. For example, this patient here, the algorithm has predicted that she will not be operated with a prediction of 95% probability that she will not be operated. But the algorithm was wrong, okay? So who is this patient? Is the algorithm wrong, or is this patient just an outlier, just someone I couldn't predict myself as a clinical expert? And I can see the particularity of this patient. So, for example, this patient, she had pain in the legs, 10 of ODI, 1 of ADS. So she didn't look like someone who would be operated. So maybe the algorithm is not that dumb. Maybe this patient is just an outlier. I can also see which variables explain my algorithm, okay? So the main reason for consultation, the ODI, etc. And I can also see that 87% of the performance can be explained by the top 5 most important variables, which means that I can simplify my algorithm. And instead of asking the patient like 20 questions before the consultation, I can ask him only 5 questions. So it's much easier to implement the algorithm in clinical practice. And finally, an SAMD, a software as a medical device, is just like a drug or medical device. There are good use cases and there are bad use cases. So there are indications. So I can see in which specific class of patients my algorithm is good or bad, okay? So I can see, is it as good in young and in elderly people? Is it as good in male and female, etc.? So I can compare the populations. And finally, we need to simulate clinical situations because all of this is quite abstract to me. It's quite far from our reality. It's like it's many numbers. So let's take some examples. Let's go to prediction. We'll take a woman. She is not employed. She doesn't smoke. She has back pain, very mild back pain, you see, and she has a good clinical score, a good ODI. The probability for her to be operated is only 1%. I do agree. As a surgeon, it's okay. What if she comes for leg pain, for example, with a higher ADS and lower clinical score? 11%. It's quite good. And I can explain to the patient why. Because of the ODI, because I can explain to her. But also, what happens if the patient has different ODI, the same exact patient? I can simulate this patient, and make the ODI vary continuously and see what happens for this exact patient if she had answered something else. And I can draw a chart seeing the probability of being operating for this specific patient according to her ODI, which is very interesting. I can also say if you lose weight, for example, your probability will decrease. So I can give advice to my patient thanks to that. And finally, last step, if you want to do a medical device, you have to document. Like you said just before, Bruno, it's very important to have a very documented technique. So everything is automatically logged into the application. We also have developed this checklist that allows you to follow guidelines and to document these guidelines. So for example, you will say, I use pseudonymized data, you will document it, save it, everything will be stored and tracked. And then obviously you need to publish your results, whether it be scientifically or for a regulatory standpoint. So you go to publication and you will have automatically some content which is generating. Okay, so to conclude, you can create your very own predictive AI algorithm at 3 conditions. First, you need to have very good data. Secondly, a clinical expertise, and third, a good tool like Scienter or any others. Thank you very much.
Thank you so much, Michael. So what are the next steps between Scienter and SpineDAO?
So we will start with a filter, hopefully, and implement it to do a clinical study because it needs to be validated also clinically.
Yeah,
it's not enough to do like the technical part. We need to clinically validate, and then we can expand this to anything that we want to measure. So it can be an outcome. It can be like sick leave. So you can predict to the patient how long he will be out of his work. If you will need further surgeries, Anything can be predicted. We just need the good data and the expertise.
We have a data set for infiltration and steroid injection. We have that. We can run something on this data set. We have one. Yes, we have big one. Yes,
No, just sorry.
yes, yes.
Interest.
And then the DECIDE project, we have to take our patient with a 2 years follow-up, I think. But it's a big project. But your question is not for the project, it's for science or no?
No,
The
I
question-
think that it's already done.
I think what is the next for me, what is the next step between Sciencer and us? For me, what is the collaboration? Will be partner, will be
we
together.
We are already partners, for sure.
We are respondents.
Yeah.
I do agree.
Thank you so much, Michael. So, because we are in a rush, let's go with Federico. Federico. Federico Nicolesi. Nicolosi.
Tu vois, c'est pas moi.
Welcome, Federico.
It's not me. I have a problem with my name
Because
I thought it was an easy name. It's not.
Yeah.
Everyone,
So for those
they
who
change
doesn't
something.
know, Federico Nicolosi is CEO of Upsurgeon. Upsurgeon that is probably I will resume it too easily, but a training and educational company that starts on brain surgery, so on neurosurgery mostly by brain and skull simulators for simulating surgery and augmented reality on the boxes. And now they are expanding in many other fields, but I won't say everything about him. And he's actually a neurosurgeon from Milano, and now he almost quit neurosurgery. Almost, you're in a break for your practice of neurosurgery.
And we think is the
You never quit neurosurgery.
I quit.
Yeah, you.
That's how we can.
I can't quit. You
No,
should
that's
die
great.
to quit. Yeah.
hey, but we
Especially we do work with stuff that can be.
And I know Marcia from Sicily, so I know that
You know,
I can say.
and we think you have his place on SpineDAO for the education pod and for the education part, because we need to educate surgeons, not maybe for the patient, but this part will be for the surgeon.
And super sorry, but remember, guys, that we only have 10 minutes from each speaker, but you can do that.
I will go first.
Sure.
So thank you, first of all, to invite me, to the organizers. This SpineDAO initiative for me was a very inspiring idea. And in my opinion, connecting dots, connecting different realities is the only way to progress. So thank you, John, Francois, my friends, Joseph. And so what I'm going to talk about is another kind of data, performance data. So we are talking about surgery, so we need to talk about how to certify surgeons. If you look at me, you have no idea of who I am, but most important, what I am able to do surgically. So you have no idea if I'm a good or a bad surgeon. So this is all about we are talking. And so I am involved with Upsurgeon, as we said. I want to start from this concept very quickly. There is a lot of technology, there is a lot of inspiring things happening, but in medicine, it is a strange fact that if you go from a discipline to another, there's a completely different level of development. So you can find super technologies in one, and they are still very behind in other things. And the point, the training is changing today, and this is a good news, because before we were training in a very randomic way. So we are moving from a circumstantial practice, so very randomic, to an intentional practice. To do this, it means that I should have a surgeon in front of specific cases and specific conditions and the complications. But the only way to do this is with simulation. And the way we learn is not something that we are inventing, it's something that's very well known in a discipline. If you practice sport, if you practice music, it's so obvious that you need to train. This is not obvious in surgery, because in surgery what we do is starting from the first day, we enter operating room and we start touching patients, which is not bad, but this is the traditional way, and probably there is a better way to do this. The problem is that the more we expose ourselves to an experience, the more we learn, but also if we don't come back and recall this memory, we we lose everything. And we are talking about many, many different conditions. And my first surgery on a young patient with a brain tumor was on a real patient, obviously. And this was a young patient, and I was a fourth-year resident. And I needed several things, not only the patient with the pathology, but also the master trusting me to give in my hands as a first operator the instruments for the first time. This is a very randomic situation. So the concept is that we are not trying to replace cadavers. We are not trying to replace that system, or we are trying to integrate with simulation. I will talk about cranial surgery because my background is mostly on the cranial side, and because I am talking about some results that I want to bring with you, SpineDAO, to the spine level, to the spine research. So cranial surgery, this is what I was more, let's say, this was my focus during the residency and the early years of my career, brain tumors. And I will do an example of what we need to learn in neurosurgery is microsurgical skills, micro dissection. This is an example. But then I want to bring you, let's say, here. This is a situation where I'm not a vascular surgeon, but this is a vascular surgery, so for an aneurysm. So somewhere there is an aneurysm, and the surgeon is trying to understand where is the aneurysm and trying to clip it, to close the vessel. This is obviously a senior surgeon. This is a real video. This is not me, fortunately, because what at some point you see is that you have the anatomy, the carotid, it's very deep and narrow corridor, under the brain, and suddenly there is a rupture of the aneurysm. This is a very scary situation, but this is just an example of a scary, sudden complication that you need to be able to manage. So the question to you is, how can we teach people to manage this? I should have people with ruptured aneurysms. So the reality is that the tradition brings us to do so many errors on patients during the years. And in other words, this discipline is going to die because there's no way today to treat these patients, or let's say, to teach new residents on this kind of situation. And also because in this specific case, we are using a lot of endovascular surgery. So it's very difficult. So the point is, after a complication in any surgery, you may say, I made a mistake, I will go there and try again in the next case. But if you want to do the comparison with pilots and aviation, it's like to say that after a aircraft disaster, there is the pilot coming back there and saying, oh, this was bad, I need to do better next time, this is impossible. So the point is, the way we do today is certifying pilots with advanced simulation. That's why it's absolutely a reasonable thinking to imagine that as we did in the pilots, we are going to do the same in surgery thanks to data, thanks to advanced simulation. And that's what Absurgeon is doing. Absurgeon is trying to fix the problem that we jump directly on surgeons and patients. That's the day one. And obviously, this is obvious. There is a fantastic community of several sciences today here. So in any discipline, what is happening is exactly the same thing. Data are changing the way we train people in different professionals in different fields. So the problem is not the simulation, is not the cadaver. The problem is that there's no way to objectively measure talent. How can you measure the ability of a surgeon? That is the problem that we are trying to fix. And so with this Absurgeon, I had the possibility to introduce this reality funded by surgeons. I am one of the founders. A group of neurosurgeons joining together with the engineers, digital artists, experts of materials to do three things. Virtual reality on one side, a life situation simulation on the other side, and mixed reality. I will give you some.
For me, this is a real revolution in training.
This is to understand what happens.
The new horizons.
I really feel like the residents and fellows and medical students all get so much more out of using this system.
I was very impressed. Actually, a lot of the learners were very impressed with the amount of detail with the anatomy.
The virtual reality and the app is very tremendous for the residents. It's something that they can go back to, and we thought was very useful.
Just reinforces the anatomy and surgical approaches in 3 ways, and 3 times repetition, which really just reinforces the concepts of the structural anatomy and the approaches for the students in a way that I've never seen before.
BrainBox
boxes are changing the way education works.
I've had the wonderful opportunity of talking to some of its key team members and their vision, and I've been truly left with a great sense of hope and inspiration from what they're trying to do.
Oh, I'm bringing out the fire, bring on all the lightning.
And I think this is an amazing way for residents to get hands-on experience and devote a lot more hours to this than they would normally be able to.
Carry the hurt when it gets too hard, pick it up, dust it off.
This would be very interesting also in lower developed country, where the possibility to reach a lab which is so simple, so you can put it in a box without requiring the setting that cadaver lab will need, is very interesting.
Education is now possible anytime, anywhere, and also for everybody.
So this activity literally exploded in our hands, and now we expanded in many countries, working with many institutions and moving from neurosurgery to spine to plastic to ENT, and we are expanding in other disciplines. And what I'm going now to tell you is what happens in these simulators is a unique opportunity. I mean, this is not a patient, it's not a cadaver. So basically we can do whatever we want inside the simulator, also collecting data. And that is the challenge, and that is what I'm going to show you now. This is an example of data collection and the first validation of this data in the traditional way of thinking. I mean, collecting data from video, so observers, but evaluating with scoring systems the quality, and already this kind of data gave us validation. So this kind of data demonstrates that this kind of activity create improvements. I will give you another example on spine, just because obviously it's important for the topic. There is an anterior cervical surgery in a simulator, and you see a master. The master in this case was the director of the residency program of Stanford with a resident. So the point of this surgery is to identify the carotid, so the pulsation and the detection of the carotid, and at some point the visualization of the tissue. So first time ever the synthetic tissue pulsates and give you the feeling of being inside the surgery in the condition of being also close to a potential complication. So you need to be able to manage this. Of course, there is also other kind of simulation that we are doing about the, let's say the music. For example, the endoscopy, we are working with Francois. Together we created this kind of technology for spine surgery and endoscopy, and now we are working with the community to extend to a certain level. So the point is the emotional impact, so giving a realism that is not the realism that we can find on a piece of silicon. The point is not to replace silicon toys, but to replace cadavers. So this is a specific methodology. I will accelerate now because I want to show you an important study.
You have 1 minute and a half, Federico.
See, I'm going to finish. So what happens now? The possibility to collect data is what is happening now. So these are the first step, these instruments, but now what we are doing is a series of studies where we are collecting data that is impossible to collect on a cadaver or a real patient. This is not just rendering, this is what is happening. These are prototypes, and we are creating the first AI coaching. And I will show you the first study results on the cranial side, but that's where I want to go with the conversation to understand how we can merge forces and go together. This is the first prototype of a cranial simulator where inside there is a system to collect data from the tissue. And this is the setting where you see the operator approaching an aneurysm and doing a specific procedure, and a system that is collecting the data. And this is the first study where we compared the group of residents with few experts. And the results are incredible, because after few tasks that the residents made from several schools in Italy, so it's North Italy, at the moment we did all our statistics, this was what they were going to do. So surgeries to declip and detect the aneurysms. This video shows you how it is made. Just to understand, this is an electronic inside the simulator. So it's not just the soft tissue, but a system able to detect events. And at some point when you touch the tissue inside the simulator, everything is connected with an app, and you start seeing events, forces, pressures, deformations, and many other things. What happens after this? The results were incredible. So imagine bringing this to a level of spine, so having the possibility to collect this kind of data in spine. And the result has been that for the first time ever, we have been able to create a system able to distinguish experts from non-experts in an incredible way. So the system didn't know who was operating, and the classification was exactly scoring the level of the person, even in the precision of the hands. And this was another incredible discovery. Now we are, let's say, enlarging this experience. And the point is, let's go together to bring this kind of results on the spine. And inside the non-experts, this was amazing. We identified the best ones that were confirmed in the tasks. So it was consistent with the results. And any time we changed the results. So the names in the beginning of the classification were always the same and were the better in the general scoring. So at some point, this is the last slide. At some point, what we can do is to start together a collective research where we try to understand what is talent in spine surgery. What we need to define a good performance in spine is force on a tissue. It is the way we drill. It is the way we touch a nerve, whatever. So this is now the point where we need to identify 1,000 of parameters, and the statistics will tell us 90%, 95% will be useless, but there is a 5% of potential markers of talent in spine. So that's what we can be, and imagine this able to certify surgeons at some point. And absolutely, a big business for insurance companies and a big interest for healthcare providers and for patients, of course.
Yeah.
So that's
you're able to evaluate the praxis.
Yes,
that's totally great.
And in terms of social impact, we democratize the opportunity.
Yeah,
the better can be anyone.
Take some time to train the robots, because I have 20 years to practice.
Absolutely.
So you can take your time to train the robots from this data. Thank you so much.
Robotic surgery, yeah.
That's a new presentation from Marseille. Yeah. That's new insights.
Yes, it's a few days ago results.
Marseille was 2 months ago. Slow down. Take some rest.
Yeah, so I will try to be concise. Yeah, 10 minutes tops. So I'll present what we do and what we can expect from the collaboration with SpineDAO. So we basically do medical software as a device, software as a medical device. So it's called on the term, but it's a surgery medical outcome. So you can shorten it as SUMO. So if I say SUMO at some point, you know what it is.
I love it.
So yeah, that's our focus was on main focus when we started was on the patient. So basically, we wanted to be able to detect what would be a good or bad patient for a surgery. So yeah, basically when we started with a patient in mind. So we developed a medical device. So first, we won't talk about all the steps. We started with a study, and then we built from that. And as I said this morning, very important thing when you're building a medical device is the legal and compliance, because that's a lot of work. It has to be taken into account when you start. We didn't take it too much into account when we started with Jean-Jacques, but we learned to be very, very precise on that. So just to summarize what we do, our software is a medical application, an application on the phone, so a smartphone that will collect data from the patient. Data will be collected at the first consultation when the patient sees the surgeon. Then along the pathway, we will collect data from the patient. So it's all based on prompts. So basically the questionnaire the surveys that will be sent to the patient, they will answer them by themselves for what we are looking at. So we are gathering that information, and then we make prediction on that data. So prompt is very interesting because it will give the surgeon information on what the patient really feels, because we are using similar stuff as UD4 filters, so EDA pain scales, ODI also, which is an indicator of disability of the patient. So I put the whole thing there, but you can read it. It's not, the thing is not really important on how we do it, but more on what you have to do to be able to do it. So this is a regulated system. So the medical device has to be marked if you want to be able to use it in real life, and you have to be able to show that you have all the requirements that fits the procedure. So I just presented one of our results from the study that we did to be able to be marked, and that's just ODI, collecting ODIs before surgery and after surgery up to 400 days. So it's more than 1 year. So we have long-term collecting of data from the patient, and also, as I said, you have to. So we said that we have to publish. You have to publish what you do. So we published it in 2022, first article, and then we are in process of publishing another one, which is a follow-up of what we published the first time. And it's very interesting because the next article is about the data that we gathered during the study, the second study that we did. So you see that's not a short process. It takes time. We were published in 2022, and we started writing the article in 2020. So it took 2 years to be published, and the whole process took 4 years to be able to be marked as a medical device. So what we do with our medical device is we have three solutions basically. One for the patient, which is a tool. So I said the Sumo app application that will go to the patient. They will give the information, the medical information, but they will receive in return personalized path care for after the surgery. So it's what we call a DTX, so digital therapeutics. Then you have the second part, which is the data processing and AI. So we gather that data, then we make a prediction on if the patient will be a good or bad recipient for the surgery. So I put all the relevant information that we have 82% of accuracy to detect failure or success on long-term follow-up. So that's what we have from our study, prospective study. And also we managed to measure the improvement of quality of life with comparing the ODI from baseline to up to 1 year after the surgery. And this is done by the application, the collecting of data, and the fact that we can compare what we have at the beginning and what we have at the end. And the third part is the solution for the surgeon. So the data is collected and then presented with a dashboard to the surgeon. So the surgeon can be directly informed on if the surgery will be good or bad, and it can also follow what's happening with the patient, not remotely. So it doesn't need to see the patient to see what's happening. So it's basically a threefold tool that we have. And so about the collaborative aspect of SpineDAO and Cortex Medical Intelligence, I think that we are on the same page regarding what we want to do and what is good for the surgeon and patients. And so we plan on collaborating with SpineDAO because we think that SpineDAO is a very, very good mean to have access to patients and surgeons and to democratize the technologies. And we have, as I said, we have a medical device that can be used in real life by the surgeon and the patient. And that's key if you want to be able to deploy the solution quickly and also effectively. I think that's the last one on our perspective. We have three parts on our perspective. It's defining, democratizing the monitoring of patients, which will allow access to real life precision data and also care for the patient. the development of collective intelligence, as we saw during the day, is very important also because we think that there is a lot we are just at the beginning of our journey with that medical device, because our medical device has been developed with some surgeon, but not all of the surgeon. As we said, we need to have different point of view to improve the accuracy, to improve the resilience also of the algorithm. And also we are starting to look at all the data that we don't collect at the moment. So I'm thinking about imaging data, and also recently we partnered with Greco, which is a robotic institute for part navigation robotic. So that's a grant that we just unlocked recently, and it will allow us to include also that kind of data in our algorithm. And that is done within the revelation. Then when you include new data, you can make a new version of your product, improve your accuracy, and then you build on that, and you build until you get the perfect tool, but takes a long time. So
No, that's in my perspective, it's just a spine accelerator. I mean, just the intelligence boiling. And with this partnership, we will accelerate our project and research project. Thank you so much.
From a regulatory point of view, right now you're more oriented toward like Europe.
Yes. For now, we are CE marked. So basically, I think it is maybe not the hardest, but probably the hardest regulation that you have at the moment anywhere.
Yeah.
So and if you want to go to the US, because I think that's the big market, then you have to. There is bridges that you can use to convert what you already done to the CE.
Yeah. So like for the US, you're gonna need like a quality system which you already have.
We already have.
Yes. You have to do that for CE mark, and then there's just a technical file. So
it's this way is easy.
When you used to have our software, unfortunately I was in charge of the regulatory aspect. I made a point to forget everything. So don't ask me. But the most painful part was like the CE mark.
Yeah.
The FDA was a breeze in comparison. That's cool also, but not as much.
There is a lot of quality to be done with the CE, and then when you go to the US, it's.
You know if there is a predicate device already in the US?
No, I don't know.
No.
Yeah, let's work on the US markets because.
Finally. But we can go.
Yeah, we're in London.
We had to wait like 4 p.m.
Can you believe it? Let's work on the US market.
We have some guys from Artifact now.
Yeah,
with the talker.
Sébastien, yeah, perfect.
I go first.
Okay, perfect.
Present something to
Artifact. So Artifact is hosting us. Thanks
you again
for hosting us. Thank you so much.
Thank you so much.
I think the kitchen is quite clean. Joseph, you.
No, it is incredibly clean.
Yeah, incredibly clean.
Yeah.
Thank you so much.
Thank you, Suman.
Good afternoon, everyone. Thank you so much for being here to listen to me yap about healthcare a little bit. I'm Sumant. I'm a senior data science manager at Artifact. I just want to talk a little bit about how we can move away from silos and towards a universal approach regarding healthcare. So, if you didn't know, the World Expo 2025 is happening in Osaka, Japan this year. The 2020 edition was supposed to happen in 2020, but then it got pushed to 2021 in Dubai. Many of you might have been there. So it's happening in Osaka, Japan from April to October. Check it out if you are. I've always wanted to go to Japan. It's one of the healthiest countries on the planet. And so the theme for this year is how do we design societies? And one of the biggest sub-themes is longevity, healthcare, diet, and exercise. So we could all use that. So check it out Osaka from April. Anyway, so a little bit about myself. I cut my time at the University of Toronto building image processing systems for underwater robots. And then I did the same thing. I used image processing systems at SpineDAO, and then at Cited, I built foundation models for the gut, specifically focusing on something called Barrett's esophagus, which is a pre-carcinogenic condition. And I published in Nature as well. So I worked in image processing and then computer vision. I'm a scientist by background. And then now I lead data science at Artifact. So the problem definition, so I just want to present a problem which is prevalent. All of the research that's done in healthcare, whether it's by isomorphic labs or anybody else, it's done in silo.
like, that's the AlphaFold 3 module, which predicts the protein structure from a single sequence into a 3-dimensional structure. And then that's boards 1, which is the PyTorch implementation of AlphaFold 3, same thing. And this is something called a sec-dance model, which predicts the dynamic properties of proteins when they're undergoing a reaction. Because as you know, when a chemical reaction is happening, the speed of the molecules also make quite a bit of difference about the speed and the orientation of the molecules. Yeah, so just a quick intro about foundation models. I'm sure everyone has heard about DeepSeek, which is which has reduced NVIDIA stock. Good time to buy, I guess. Claude is my favorite, and then you have Gemini Deep Research. I haven't used that yet. I want to check it out. So foundation model essentially takes a large amount of data, text, video, audio, what have you, and then it teaches the system what to do with that data so that we can use it to generate a wide array of results, whether it's making financial decisions, whether it's making a workout plan for myself, and so on. So the original problem of moving away from research in silos, we need to go into something which is more akin to a multimodal architecture, as we've seen in many other models. So that's a multimodal architecture, and that has to be applied to healthcare. And two other techniques which we can have apart from CNNs and transformer technology is graph-based neural networks, where the nodes and the edges represent relationships between various entities. And you can imagine this as so the foundation models in which I envision for biology, they should not be of a singular function. They should be able to take a particular disease or a condition and then map the entire network pathway from brain to anywhere else. And that involves a whole bunch of components for which multimodal architecture, graph-based neural networks, and Bayesian reasoning are best suited. And these three are the three sides of a triangle using which we can develop these. And then, so I was just talking about this, extending foundation models, how we can do this. So specific diseases, conditions, mapping those is much better than mapping the individual elements such as proteins or DNA, which we have many models for. And then specific diseases and conditions is a function of proteins, DNA sequences, and methylation data. The capabilities, as I said, this is most important. Capabilities of such a foundation model should be root cause analysis, identification of relevant biomarkers, tracing the network pathway, binding site localization, and potential drug discovery. And just pay attention to this on a personalized level. Like for me or for you, it should take up the model should have the data of all your biomarkers, and then with every one of your actions, you should be able to give us the delta of the biomarkers, how eating a particular food is going to change, how traveling to a country might change your biomarkers. And then, potentially saying, okay, you're going to live up to 105, 120. Personally, I don't want to die and live up to 130, but, depends on you. So anyway, the techniques we can use here are graph-based neural nets, multimodal data sets, and architectures, as I showed you guys. The biggest problem to developing such models is the bottlenecks in data acquisition, essentially scientific literature. So these are some of the data sources which we can use, and I have used these in the past during my work. One is scientific literature and preprint, bioRxiv, PubMed Central, Nature, Science, and Google Scholar. And the molecular structural data we can obtain from databases such as PDB. PDB was a database which Google, DeepMind and Isomorphic Labs used to train their AlphaFold 3 and others, GenBank and others. We have clinical and medical data. These are incredibly accurate, and these are more important than some of the molecular and structural data. Biological networks, we can train them through Reactome, BioGrid, and other databases. And then the UK has a bunch of projects going on, such as the 100,000 genomes and the biobank, from which we can obtain sequence data. And then finally, we have real-time data sources. These are what's going to inform the Bayesian reasoning of the model. As in, like, we have a set of priors, and then new data is coming in, and the priors have to be updated using Bayesian reasoning. So real-time data sources are incredibly important as well. I kept the talk really short because I want to have time for a couple of questions. And these are some of the articles and the papers that I've written, and go check it out if you're interested. Thank you so much for that. Any questions? Yeah, in 3 minutes.
Question, that's okay?
Go. Yeah. Just one question for someone, like, how do you imagine the modeling of the spine with in complexity? For you, it's like a protein structure. It can be like a protein structure, or we can do that. We can algorithm the spine with all the dynamics and muscular. Yeah, it's possible.
So the spinal fluid is one of the best sources of, how the spine can behave. Right? So I've had my spinal fluid taken out for a particular condition that I had. So we can extract biomarkers from that, actually, because each and every condition that we measure is through a biomarker. Some protein level which should be within a particular range. If it's outside of a particular range, then something's wrong in your body. Yeah. Right? So spinal fluid is the source of the biomarker for these kinds of models.
Super interesting. So let's study CSF. Let's you into the CSF. Thank you so much.
Yeah,
Thank you so much.
So thank you very much. The story started. I incorporated the company 10 years ago, but the story started long before. I did my residency in Toulouse, south of France, and then one of my boss, very humble, told me, there are a lot of different ways to practice neurosurgery. We don't do all the different techniques, and we don't do all perfectly. So you have to go see by yourself the other bosses, do a lot of fellowships, do your own technique, and get back. So I went to Marseille, to Bordeaux, Paris. I ended in Montpellier, and then I realized, what if I could have put a GoPro on the forehead of all the professors that I assisted during all these years? Then, instead of one GoPro, we put two GoPro. We came with a hardware that the surgeon is wearing while he or she is performing the procedure to capture the only way you have to understand all the details, the first person view. The first person view is the point of view that you never had. And this is why we spend a lot of time being in OR, beside or behind, without understanding all the details. Then we created an app, virtual reality app, to display the content. I will show it to you, and a platform to deploy it. We worked out first with medical device companies to promote their techniques and their products, and then step by step we created off-the-shelf content for the nurses and the caregivers. Now what we want to achieve is an immersive encyclopedia, the possibility to archive knowledge from the experts before they are being retired, and this program is called the Immersive Chronicles, to keep it for the next generation. And for the actual generation, we are creating the basic surgery content, which can be available and worldwide for each different specialty. And we do it on live cadavers. This is another technique. Finally, we are cross-specialty. And on the R&D side, we are working on computer vision algorithm to reconstruct in 3D the operative scene, to be able to interact with the video, but also to understand more the different steps of the surgery to make surgeon and machine being able to cooperate together. So this is where we are, and I'm super happy to join this opportunity and to support the SpineDAO, because I really think this is our DNA, sharing knowledge across frontiers. Thank you.
Thank you very much. And the bridge is super easy to make, because I know like plenty of surgeons that are super technical, that want to bring something to the DAO, and they want to bring their techniques and their practice to the DAO. So this solution is totally fit with our project. Incentive in Spine Token for the surgeon, for your company, and then make a educational specific educational program on all our techniques and all our surgical procedure. Now we can move on Sébastien, maybe? Allez, let's go.
Kind of early. So, hello everyone, I'm Sébastien. I'm Director of AI for Health by Artifact. So, today I'm going to speak less technical than the ones you have before. I'm technical only in the life science aspect, as I'm a bioengineer by formation. But today I'm going to speak about all the offers and all the aspect we have in Artifact, because you may know the consulting part, but we also have an open innovation department here at Artifact, organizing different conferences, organizing different aspects you may not know. So my role today is also to give you a little glimpse about the ecosystem that we have here for health in France, in Europe also, and to speak about another event that we will organize and that, of course, you will be invited to. So, quickly, Artifact Open Innovation, we're focused on the data and AI acculturation along with Artifact School of Data, which is also on the formation part. We are specialized in training and adopting, helping the society and the entities adopting AI through all their different aspects and all the departments. So we organize hackathon, we organize Gen AI acculturation and problem challenges to embark both the C-levels onto the operational teams. And also we organize international conferences with all different ecosystems. One of our biggest one is AI for Health, which I'm directing right now. And the idea is to create this ecosystem, which are open innovation ones. So in the open innovation ecosystem that we create here in the Artifact Open Innovation, we've created since 8 years 6 ecosystems that are focused on different sectors. One on health, the other finance, etc., etc. They all share the same purposes, which are identifying the AI use cases and some promising startups. So from the pre-seed, we're trying to see in France and in Europe who are the next best startups to focus on in order to have them in our conferences. Also identify KOLs and the new trends for the conferences. But we're not only doing events, that's the important part. We're also connecting with different stakeholders, public and private ones, in order to bring the people with the ideas. One of our main concern was the fact that some startups or some companies didn't have the chance to speak to the right stakeholders, to speak to the right person, that they were facing challenges to, to get in touch with regulators, to get in touch with deciders and stuff like that. So our role is also to be like the interface between different actors. And last but not least, we share a global mission of acculturation. So we want to break silos between public and private, but also within the different part, within the public institutions and within also the private, like the big companies and the startups. And also we raise treaties and we connect with authorities, deciders and regulators, both from France and the European Union, in order to help things move a bit. So we're not in touch with the NHS for the moment, but when we're going to bring and build this UK ecosystem, that's something we will definitely focus on. So really quickly, so we organized the biggest and the first AI for Health conference. So we organized it in Paris, historically in Palais de Tokyo and then Station F in Paris. We reach more than 2,000 people annually in this conference. It bridges from startups and different maturity of startups to big companies and passing through public institutions. We have some KOLs speaking to the conference also. And this year, we're gonna bring a new dimension directly to this conference. That's a little teaser for right after. So quickly, this is our ecosystem for the health aspects. We have a lot of partners, a lot of people participating to our conferences. In fact, we were co-founded by Johnson & Johnson back in 2018. And also we have a lot of tech and corporate partners, pharma, of course, partners, and public institutions. The idea also, that's why I'm here, is to start connecting with UK ecosystem at some point, because we start knowing well the French and EU ecosystem, and more we just see that rises a lot of promising ecosystem in the UK. And last but not least, you guys have now a strategy for AI, so that's something that we're really interested in. And a lot of startups here. In fact, one of them is from UK, Generics Life. So the idea is also to widen all the contacts that we have in order to bring connection, that's our mission, and to create value. One of our KPIs is the number of startups we connect with good companies and the number of acquisitions they have. Awesome. So that's our role. Quickly, if you come to the AI for Health Summit in the conferences, so this was the numbers for the 7th edition, you will mainly see pharma companies, a lot of startups, healthcare professionals, and medtechs. So these are the big personas we have at the moment. And about 1 out of 2 people are at least VP or directors. So this is the kind of personnel also we have in the conference, which means that our role there with AI for Health is to create like the good momentum for people to connect, both in the event, but during all the year, and creating different aspects. So like, for example, we organize specific workshops to work with public authorities on, helping, having clinical trials, integrating AI, for example. That's something we work in France on it. And in French, we love to regulate. That's the part, which is about or good things. I don't know. I'm not here to judge. But the thing is, this is also what we do. Is all through the years, not only an event, trying to help innovators to have their innovation on the road. So this was for the quick presentation, and I'm gonna be quick for the end. I just want you to look at our next edition, which will take another dimensions. As you may know, the AI Action Summit will take place in Paris in February, in the Grand Palais.
February?
In this February, yeah, the Action Summit. So it's an international gathering of all the different countries speaking about AI. And we are organizing Adapt AI in the Grand Palais in September. So this will be really big. The idea is to gather all the ecosystem that I mentioned earlier. So the one on finance, the one on health, the one on luxury, the one on the planet, the one on sport, etc., etc. To gather them on 2 days. So 16th will be for partners and 17th, 18th will be for all the audience. The idea with that is to be in the continuity of the AI Action Summits, which is more focused on the policies and the global aspect. And we want to be the follow-up of this summit for the companies, the startups, and the public society. That's also why we're doing it here. So that's kind of a save the date also, and it's a great ambition that we have here for Artifact and all our ecosystems. So this is the ecosystem that you have here summed up, and I'm passing quickly so that you can see there. But the idea is that if we come back to the aspect what we'll do it, this is the Grand Palais. So I don't know if you had a chance to go to Paris and go some ice skating there, because they have good ice skating there. Just to quickly have you in mind, this is really big. And for this event, when you enter and you can go to the AI5 different demo zones and the program for the main stage and the startup stage and the masterclass stage, the idea is that you will find here what you need for the health ecosystem. So specifically for example, you can find all the stakeholders from the AI for health ecosystem there. But if you're interested and curious in knowing other industry and going to other places, that's where you have to go. And also we have a CEO stage where we will invite all the big CEO from big startups and big scale-ups, and big companies, just like Sanofi. We'll probably have Polizzi. We'll have also the opening by Emmanuel Macron, also, because it's the follow-up. And that's a good ambition that we have. And that's also why we're here in UK, because we think we lack this UK ecosystem to bring to this conference also. Well, quickly, we have a scientific committee helping us to build everything. All my emoji are going out. But the idea is this. And last but not least, so the idea, that's why we're doing this presentation also, is to see whether there's an interest for you or for anyone you can have in mind to join this ecosystem, participate to this event, or I will just keep in chat and try to build something maybe in London or maybe in other countries. So that's kind of all for me. That was less technical. Maybe it can ease your brain a bit. It was more marketing, and just for you to know, because it's more technical on this part, we work a lot with the Artifact teams, the consulting ones, also to build different reports and analysis. The one we did in 2022 about the generative AI, and another we did this year, about how AI revolutionizes drug development. So that's also another part of our job, is to connect with our ecosystem, have them showcase in the book, and give a report. So also, if you're interested in participating in one of our reports, we keep in touch, and that's it.
Thank you so much, Sébastien. I have one question.
Yes.
Does Artifact has a Web2 wallet?
So what?
Does Artifact has a crypto wallet?
I'm not sure what that.
That's super good because as we want to be the portal from between like the real world and the traditional world with the Web3, I think that this collaboration will be just perfect to go on.
Let's just keep in touch.
Absolutely. We will be there in Paris.
I am with pleasure. Like if I have a contact with you, I can just send you an invitation.
Thank you so much.
Yes.
Your network is huge. Thank you so much, Sébastien.
Thank you.
Thank you very much. Now we get Steven.
Yes.
Let's go.
Steven,
So it's a long story with Steven. A few years of collaboration between Follow and Spine Research Community, and we can say that we are kind of the flagship of Follow. Like we are the community with super well structured data. C'est vrai, Tata?
Oh yes, it's impressive.
Yeah, for sure. So we transform this office manager writing prescription and document and medical documents in a super data silo, and we think that this collaboration could scale up globally with SpineDAO. Thank you, Steven, for coming here. Thank you so much.
Thank you. I'm Steven. I'm the CEO of Follow. My name is Steven, but my English is very bad for business. It's good for holiday. So medical time is precious, and we want to take care about it. We started with scientific research, followed by the development of specialist software. And Follow is designed for surgeon and a specialist doctor. This one is before Follow solution, and now after Follow solution. But now we have two or three, 90% surgeons have a solution like this. Peut passer aussi. You have lots of functionality in Follow. You can manage all your operation. Je passais la démo, c'est le plus important. We have more than 200 physician investors in the capital. We have also Xavier Niel and Christian Guillemot, Ubisoft founder and Free founder. And we are 42 employed in Follow. And now we want to show you AI by Follow in a few months. Well-structured Follow database day one. With Follow, no more Excel, file for studies, no all one. You can see example. You can request information related to your medical data very easily and anytime.
So it's a chatbot.
Yes.
Great.
Based on what? It's ready.
Based on Gemini. Okay. The Gemini, no?
Gemini. You can work with several people in a team like SRC. And you have a black box system in accordance with legislation in France, 100% secure and 100% euros.
So GDPR
see example. Yeah.
GDPR, perfect.
It's ready in 3 or 4 months.
So it's a chatbot to
with your data.
Yes, to have insight.
Yes, you can manage your KPI with your patient.
Excellent.
Export, it's finished. All is this
from the chatbot.
Yes.
Super interesting.
This will be replaced the export system solution.
Yes.
Okay. Everybody knows Follow. If we just maybe I can show you my.
Yeah, show me the little. I'm not familiar with Follow first time.
This is my Follow.
The office manager.
My office manager, just to show you.
Non, peut-être pas. Tu as montré des trucs patients sur YouTube.
Yes.
Moi, pareil.
Yeah, so that's the office manager where you see like your patient, you can make some notes, you can write some prescription as a patient.
Facturation.
Yeah,
Exactly. Okay.
That's mainly an outpatient EMR.
Yeah. Okay. But through this EMR, we can gather data.
So no data export even for research.
No.
Okay, SRC, you're dead.
All with this. All with chatbot.
With the chatbot.
Yes.
Yeah, but to do scientific projects like that.
If you want, it's possible. But it's better with this solution.
Yeah, but we so in the future we won't be able to export the CSV file.
Yeah.
Okay. So we had a call to see to create a parallel database that we can create some API to reorganize the data and clean the data. So I think that could be a solution for SRC.
Yeah, absolutely.
Say okay, you have your clinical stuff where you and your chatbot. Let's take a snapshot. Let's create some SQL query and all to reorganize and
exactly. Yeah. That's super important for spinal research community because we run the solution since 2021 and we have 300k patients on the data set with say 50k plus operated patient with 30k with 2-year follow-up. So it's kind of a treasury. So we want to keep this.
It's important for all surgeons today.
Yeah. And do you think about having from this a chatbot that is able to export automatically some crucial information to create a dashboard and follow to have this interface?
Not in the this year, but in January, yes.
But with the chatbot, we can have something like a
dashboard.
Yes, because we can ask just few questions. How many A-lift this years?
It could be interesting for the.
You can ask question and after you can ask dashboard.
Yeah, like a dashboard of specific stuff, and
but it's not a permanent dashboard, and
but
just to ask to the
yeah, because I think it could be the next step to have this image of what we are doing on a daily basis, and also as a follow user for several years. I would love to have a software that avoid me to click, just to have a box with the AI agent and have this discussion with the patient, a formal discussion. I'm focused on the eyes of the patient, on our discussion, and the box just record it and then
we have another solution, Praxi, you know Praxi?
No.
Praxi Santé?
This is the same thing that you just explained.
Okay, so you do the conversation and it exports
in 1 month. It's good.
Wow.
For all doctor in follow.
You have it with Dr. Lindo.
Yes, but not follow.
No, but
in follow, it's good in 1 month.
It's really in 1 month.
Yes.
Super version, but they will have it in product.
It's better with Praxi than Dr. Lindo.
Yeah.
And it's free.
It's super important because I want to focus on in real life.
The only thing is when you will discuss with the patient, you don't precise some specific stuff. You don't say this is a spondylolisthesis grade 2, for example, with a sleep at 35%. You see, this is why I think some clicks has to be done to have a good data and good quality data.
We can imagine that at the end of the conversation, you just dictate. You just say your letter
like Dragon.
Yes, but
like Dragon, and then he put it in the letter and he put it in the.
When you discuss with the patient or when you discuss with the doctor, you don't specify some specific stuff for research or for good quality data.
It depends because at the end, I think you need to differentiate a stuff that you need for the current way that we're doing research.
Right.
Versus stuff that we need for real life, a clinical.
Absolutely.
Versus the way we're going to do research in a few years.
Yeah, sure. For sure. But it will be a super great solution.
Yes, Michael knows Praxi Santé, it's a good solution.
Yeah, I've tested it, and you can also configure it to structure the data.
Oh, yes.
So for example, you can take the pain level on a scale from 0 to 10 and put it in a specific box. So you can also have this structured form while maintaining the virtual conversation.
Yeah. Super good.
1 month, 1 or 2 months.
Allez, 2 months.
Max.
Okay, super. Max. Thank you so much, Steven.
Thank you so much.
I think that's a wrap
for this first Genesis event of SpineDAO.
This is the first and the last Genesis,
Yeah.
no?
No, there will be like Genesis. It's still always regenerate.
Revival.
We'll always regenerate.
Resurrection, maybe.
Thank you so much for coming here. Thank you for the global audience on the live stream. And hope to see you soon. Come to SpineDAO. We will launch the token like in a few weeks. So if you're interested in coming in the tennis club, coming in the Spine Club, don't hesitate to go on the Discord, go on our X account and
LinkedIn, X, Discord, Telegram, WhatsApp, email.
Some best practices to go fast.
So you show some people. Yeah.
The guidelines to go very fast to buy.
Yeah, absolutely.
Yes.
Not a financial advice. Do your own research.
The process.
But we will communicate on that super soon. Thank you so much. Bye bye. Thank you very much.
Bye.